Good job, everyone. You have completed section 1, and now we are in section 2, where we have to learn about IAC, infrastructure as a code. You can see the overall weightage is 30%. It's like huge, right? 30% weightage. And the topics, if you see the topics, it will start from 2.1 and it will go on and on and on, and it will reach up to 2.10. Even in one section, you have so many subsections, right? So here you have to learn a lot about creating the solution, automation, different type of protocols, in detail, we have to understand all these topics with example as well. Even we have the Terraform, understand the Terraform and the usability of that. So topic is huge, topic is big. And what I will do that slowly I will walk you through one section and then other and then other and other and other and other. Like I will follow that approach so you will understand each and every topic. Again, from your side, you have to give some time, understand the concepts, the codes that you can see, try to use in your infra, because these codes are for very large infrastructure. Means like everything you have here, everything you can do with respect to automation. And we know that the code we have here, very much it is restricted to Cisco networking devices, Cisco solutions. But in the examples, I will show you codes related to Kubernetes. I will show you codes related to AWS using Terraform and all those things, which is actually not part of the course in terms of Cisco oriented course, but it is like open. Right. So there are different tools as well that will fit within the solution, within the enterprise solution. Those codes also I will show you that. And in case if you have your infra, you can test it. All right. So why not let's go and start subsection 2.1 in the next video. Now we have very important section, that is infra as a code. And in this section, we have to learn a lot. We have to learn a lot about a different deployment methodology, different protocols. One by one, I'll go and explain you about everything. Now in 2.1, we have to create a scalable solution for infrastructure automation, considering areas as network impact, risk, and tool selection. So how we can achieve this task? Obviously, you should have some use cases that will go and suit such type of scenario where network impact, risk, and tool selections are very important. So I'm going to show you one example here, and you will understand with such type of deployment related to infra as a code, we can go and achieve such task. So what is our goal? Our goal is that in long term, we should consider the network impact, risk, and the appropriate tool selection. Network impact means that bandwidth usage, latency, and security. So we want to minimize the bandwidth required for automating the task. We want the low latency, that is the communication in between the automation component. We'll see that we have the flow chart. You'll understand that you should have the bandwidth. You should, you know, once you have fully automated infrastructure, then the pieces that you are selecting there, they should not be impacted with the network. Means your network is like that you have the proper bandwidth, or in other words, you should utilize properly your bandwidth. And in case of latency also, so you should go and cater these factors, right? The bandwidth utilization, latency, and obviously security is one of the major thing that we have in the enterprise network. So secure network, communicating different APIs together, unintended, unauthorized access, all those things we should cater. Risk management means that we should have the redundancy, we should have proper failover mechanism, rollback options. Yeah. So back options will be there. That means you are doing some sort of versioning control. So you should have the option to revert the changes in case of failure. And compliances related to Again, it's a hardware software security. So compliances ensure that automated process adhere to regularity requirements. Finally, the tool selection. Tool selection means that we have different pieces, and you will understand in upcoming slides. So we have different pieces. We have infrastructure, how we are managing the infrastructure, which programming language we are managing the infrastructure, then how we are managing the configurations. For example, configuration management, we have Ansible, Puppet, Ceph. Infrastructure as a code, we have options like Terraform, CloudFormation in AWS. Monitoring and logging, we have option like Prometheus, Grafana, Elk Stack, right? So how we are selecting the tool that should be integrated and that should not have the impact related to or less impact related to network, and we should be compliant, and the impact will be less and risk will be less, like that, right? So here we have an example. Here in this example, I'm going to show you full-fledged example. I'm going to show you that with respect to Terraform, we are going to deploy the infrastructure in the cloud infrastructure. Ansible, we are going to do the management for the application, configuration management and application deployment. Then we have Docker, Kubernetes, Prometheus and Grafana for monitoring and visualization. We know about Dockers and Kubernetes. So let's see one by one. The step number one, you can see that provisioning the infrastructure with Terraform. So here you have the script. Here you have the script that within the AWS cloud, you can see this is the provider configuration. We will go and use the AWS provider. We'll go and create one network, subnet actually, VPC. One-sided block, you can see this is my VPC main. It's just the example name. Then we'll go and define the subnet resources, and then we'll go and instantiate one Linux server. This is T2 micro, that's the instance name, one server, right? And the name is web server. And in that web server, so you have the infrastructure, you have the subnet, right? You have the subnet, and then you have one machine, web server machine, where you can go prepare the machine and run these commands. These commands are nothing but install the Docker and update and start the Docker. So that means that my infrastructure is ready. I have my infra where I have one server T2 micro, and on top of that, we have the web services. Means I want to use that for web service, that's the name. But there I have my Docker installed. Now what I want, you can go and apply this configuration, init and apply, it will go and apply this configuration. So once this configuration is applied, then I can go and use Ansible for to manage the configuration and deploy the web application. So here you can see the example related to Ansible that we are deploying the web services, right? Docker is running or not. So you can see that system D is the system process that will go and check the Docker is started and it is working or not. Finally, the web application container. So then we are deploying the web application container. So you can see that we have the Docker container, name is web, and then my web, and it is latest, and we are exposing the port 88. So this is that we are doing the configuration management, manage the configuration and deploy the web application. So my container here is ready. Container here ready means that over the Docker container, we have the web application, right? Now, what we will do with the, so you can go and run the Ansible. This is the way that you can go and run the Ansible playbook. So you have your Ansible playbook ready, and then you can go and run the from with respect to inventory playbook.yaml. Now, next thing is this, that now we want to use the container orchestrator, that is the Kubernetes, right? So now Kubernetes will go and manage the containerized application across the cluster. So here you can see the example that we have two phases within the Kubernetes. For this app version 1, we have development phase and we have service phase. In the development phase, you can see that we have the name web app. We are creating 3 replicas. Application is web app, right? And this is the container and this is the application, that is the latest one, and exposing the port 80. So here you can see the explanation. Create a deployment name. We are creating one deployment name web app. ensures that 3 replica of web app containers are running. The Docker image that we have, your Docker name, your Docker image, that is the latest one. So we are using the latest Docker image and then exposing the port, so expose port 80 for each container. So for each port, we are exposing the port 80. This is the deployment. This is the deployment that we have the 3 replicas, right? We have the 3 replicas and we have the container across the cluster. Then you can see the services. Within the services, you will see that services, we are starting the service called web app service. So we are starting the service web app service, selecting the pod level. So pod level, you will see web app, that's the selector, pod app, web app, exposing the services as port number 80, routes the traffic. So anyone wants to connect with these services, they will go and use the port 80. And finally, we are doing the load balancing. So use the load balancer to make services accessible. Now you can see here that we have the infra. So we have the infra that we are using Terraform. Then we have the configuration management and application deployment. So here you have the configuration management, and then what you want to do, container management, create the containers. Even if you have different applications, you can go and create and manage the containers. So then that we can go and use kubectl and apply it, the YAML file. So my infra is ready. Within infra, my configurations that I can manage from Ansible Puppet Chef. And then to manage the containers, we have the Kubernetes management, right? Orchestration. Then finally, if you want to visualize this, you want to create this stats, chart, graph, then we can go and use Prometheus that will collect the metric and Grafana to do the visualization. So here you can see the script for Prometheus, that global a scrap interval, a scrap config. So you can see the config, and finally the job name, right? So now adding all these things, we have full-fledged infrastructure. We have this scalable solution for infrastructure, and we are considering the network impact. This is the standard practice. This is the best practice, right? So network impact, risk, and the tool selection. Again, the example for Grafana configuration, import the Kubernetes dashboard in Grafana, add Prometheus as a data source in Grafana. Let me show you the final flowchart here. So in this solution, what we are referring, that we have the developer, GitHub, Terraform. With Terraform, we are managing the infra. With Ansible, we are managing the web services Docker. With Kubernetes, we are managing the Kubernetes cluster. With Prometheus, we are managing Prometheus and Grafana. Actually, this should be like this. We are having the full visualization, and we can see the log charts and all those monitorings. As a conclusion, yes, by integrating Terraform, Ansible, Docker, Kubernetes, Prometheus, Grafana, we can create a scalable automated infrastructure solution. This solution is capable of provisioning the resources, managing the configuration, deploying the applications, and monitoring the performance, right? This line is very important. Provisioning the resources, managing the configuration, deploying the application, monitoring the performance. Each tool plays a specific role in CI/CD pipeline. We know that how it is connected with Jenkins or Git CI/CD pipelines. Ensure that the infrastructure is scalable, resilient, and secure. All right, good job. Let's just stop here. Good job, everyone. We have completed up to 2.1. In 2.2, we have to understand, build, manage, and operate a Python-based REST API with a web application framework, including the endpoints, HTTP request, and response, right? So we have to understand this, and we can go and do this example with respect to any type of orchestrations such as Cisco DNAC or Cisco SD-WAN, etc. But to make this simple, in this example, I just wanted to show you this example with respect to Cisco iOS XE. And obviously later on we'll go and build such type of programs, such type of use cases with respect to other platforms as well. let's try to understand this. Now we know one thing that is very important and to understand, that irrespective of what platform we are using, the way we are defining the packages, the way we are defining the modules, the way we are writing the codes is almost the same in all the environment. So suppose if we are understanding this particular example related to iOS XE, that will be almost same with respect to other platforms, other environments as well, where you will go and perform the lab. So you can see that you can go and use Cisco DevNet sandboxes, where you can go and reserve the lab for few hours related to SD-WAN, DNA, related to iOS XE, and there are so many others as well. Majorly in our lab, I'm going to use DevNet sandboxes to present you different type of script and their outputs. Now let's understand this. What is the requirement we have in this particular example? So the requirement we have here that we want to do is that we want to set up the environment, and we are going to use one of the Python function Flask that is there for web applications. So we are going to build a REST API using Flask. Once you go and use Flask, then you can go to any of the web browser like Chrome, Mozilla, from where you can run the APIs and you can query for the APIs. Then creating and managing endpoints to manage the network configuration, handling HTTP requested using Python. Again, in future sessions, when we'll go and learn about different type of management planes, there you will understand these things more and more. Now for testing, you can go use Postman, the GUI-based API testing environment, or we can go use curl as well to test the API. In this lab, we'll go and use the curl-based API. Right. You can go to the developer.cisco.com. You can go and reserve the lab. There are two different type of labs. Reservable sandbox, always on sandbox. Once you go and click, you will get one link. Log into that, or suppose if you do not have user, you can go and create. With different type of options are there. You can log in via your GitHub credentials or Google or Cisco IDs, etc. So that you can go and have a look. Now let us work on this environment. So what we want to install Flask because we want to test web type of application. So for that in Python, we can go and install it with pip install Flask request. And then suppose if we want to run such type of program in any of the directory, you can go and move inside the directory. Now we want to create one application. I will show you this after a few minutes in this video itself within my Visual Studio, MS Visual Studio. That this is a program I have taken the snapshot, and with this video you will get these scripts as well. You can go and check in your environment, such as suppose if you have sandbox environment, you can go and give that. I have done the reservation, so I have this IP address for one of the iOS XE device that I want to test. Now here you can see on top that we have to go and import the packages. So we have different type of packages like request for API calls. Just to negate that certificate warnings, we can go and use a URL libraries just to disable the warnings. And in the call itself, like in the API call itself, we'll go and make this certificate verify false, just negating this option. Now here you can see that our program will start, so app Flask, and I have given some headings as well. So what this will do, create the Flask application instance, then give the username, password, and the URL, then app route. So this will define a route to the root URL. So if I go and run this API with the local host with certain port numbers that I will explain you, then it will go and execute this particular output. Welcome to Cisco Network API. Then app route, we want to get the interface information with get method. So we know this thing that you have to go and define the URL. So we have the URL HTTPS that will use port 443, and then the Cisco Sandbox URL, and then the complete API call RESTCONF data IETF interface, and then the header. We have to give the header information as well, application/yang data plus JSON, and then you will go and check the response. So in the response, we can go and collect the information. And what is there in the response? In the response, we have the URL. You can see the header, auth username and password, and verify. Now, when we are talking about HTTP request, so instead of normal auth, you can give HTTP auth as well. This you will find more in the vManage, like in SD-WAN and DNAC type of automations. So here, if it is successful, print success code, and then the output. Obviously, it will go and print the output. If it is fail, then we have the error code. Then in the second route, app route statement, we can go and configure something as well. To do this configuration, you need some sort of payload. So here, the payload that we have, it will come from interface data. And while running the API, we can give the payload as a dynamic payload. So here, what this configuration will do, that you can go to certain interfaces, interface name, and you can configure the interface. So this is the URL, and then you have the response where you are you want to update an object. So you are using put method, and then you have the entire things in this entire input that you have within the API. You have the URL, you have the header, but important thing, JSON. What is the JSON? JSON equal to interface data. Where it is? Interface data is the interface input that you will give as a user input. And then you have auth username password, and again the error handling statements that if this will happen, successful, otherwise unsuccessful, or print the error code. Finally, you are coming to the main program where you want to run this application. So at the moment I'll go and run this application, the Flask application, web application will start. And within that application, we can query via GUI, we can query via the curl CLI programs as well to get the output. So here you can see that we can go and run this program, and then we can do the query. So I can do the query related to curl HTTP and the loop and the localhost IP and the port number, and then we can fetch the interfaces as well. Right, so both options we have, that we can go and fetch the interfaces as well from this program. You can see this program. Let me go and pull my Visual Studio where I can show you this program. And then if you want to do some configuration, then you can see that we have curl post method. This is the localhost, port number, interfaces, content type, application JSON, and then you have the payload. So payload is this, for example, I want to configure gigabit Ethernet 1, give a description, the enable is yes, and then the IPv4, IP and net mask. So this interface, gig1 interface, will get configured like this. And finally, we have the flowchart. So we know that Flask is a web type of application that will go and start the application. Once it will go and start the application, then in HTTP, we have request methods like get, put, post, delete. You can go and use Cisco DevNet to run these applications. And with Flask, you can go and do the query. I will show you that query. And finally, you have the API interaction with the program. Let me quickly show you the program. Let me pull my script. So here you can see that is script, the headers defining the Flask application instance, and then the username password, then the home endpoint, define the route to the root URL. And that's why you can see that you have apps, app route for interface. This is the root. And then you have the interface, and then you have interface configuration, right? So let's go and first of all run this program. So I can go here. Oops. Okay. Python dot. I am in the same directory and my program name is 2.2a. So now you can see that we are running the program and we have the program running on this particular port number. So what I can do now, I can do the curl and then HTTP querying to that localhost and 5000. Now you can see that we have this output. This output we have put here in the home directory, and you can see that we have this success code. So we are getting the output, and with the output, we are getting the success code as well. So it is returning this particular output, right? This particular output, and then we have the success code, HTTP 1.1 200. Likewise, if you want to check the interfaces, so now you can see that we have the interfaces here, the output. You can see all the all the interfaces that we have. We are getting the output. Likewise, we can go and do the post method as well. So what I have done that I have added all those script, everything code base here. With this video, you will get all these codes as well. And in your infra, you can test this. All right, let's stop here. Hi everyone, we are doing great. So far, you learned a lot about programming and how we can go and integrate the Python with API. Now, in this subsection, we have to understand, so we have to build, manage, and operate. And that's interesting. Building, management, and operating a Python-based CLI application to use REST API. Means you have to build a menu-based, a argument parser-based program that you can go and manage from your Python, and that should have the CLI interaction. It will understand your requirements. As per your requirements, you can go and put some um, some information, like as it will ask you, it has CLI interaction mode with help of argument parser. And if you type some help and some question mark, it will tell you that what you want. You want to get the information, you want to configure something like that. Like that, you can go and create the menu-based program. You'll understand this in this example. So first of all, if you want to create your virtual environment within the Linux systems, you can go and use the Python -m virtual environment, and you can use the command source virtual environment bin activate for the Linux systems. Suppose if we are running our code in the Windows, so I have to go and type virtual environment scripts activate. If I do that, then I will move to the virtual environment. That is the virtualized environment for certain codes that you want to use it. If you exit, you will come out from that virtual environment. For APIs, a call and request, we are using the packages called request. So for that also you can go and install that package. Now we have our program. We are going to use the argument parser request. We want to negate or just ignore the certificate values. So we can go and use a URL library. We want to do this a lab with some open sandbox. So Cisco DevNet, they are providing their credentials. You can go and use their sandbox. So here you can see, you can use either them, or if you have any private reservation, you can go and perform the lab there. Now, in this case, you can see rest of the body will be same. So how to get the interface? Obviously, you'll go and use the get method for HTTPI calls, and almost same thing that we have done in the previous section, right? Likewise, we have some payload. So here you can see I have interface data payload within the code itself, and then this is to configure the interfaces. So I have one function here that I want to configure the interfaces, and then I have set everything as a variable. So suppose if you want to configure gig 1, so what you need to do, you have to give the interface name, interface IP address, and the net mask. Like these things are the argument, right? Within the function you can pass this. So for any interface, means this is a function that you can use or reuse to configure any of the interfaces. And then you have the method here, put method here to update the object, or update the object. Yeah, we are using put for update, post to create, get that information and all. Now here is the interesting part we have. Here we have the CLI based Python application that we are using arg parser and description. What's the description? The description is the CLI application to interact with Cisco Network API. Then it will give you these options. If I go and run this program like Python and program name and help, it will tell you all these informations. So it will ask you what you want. You want to get the interfaces or you want to configure the interfaces. If you want to get the interfaces, then it will go and call the get interface function. If you want to configure the interfaces, then it will go and call the configure interface function, but we have the arguments for that. What's the name of the interface? What's the description of the interface? What's the IP of the interface? What's the net mask of the interface? Like that, you can go and add so many inputs here within this package, within this function. So this is just for two functions, get the interface and configure the interface. Likewise, you can go and get any type of function, configure any type of things like AAA, SNMP, get any type of information like interface, VLAN information, anything like MAC address information, interface descriptions, and interface IP addresses and IPv6 addresses, and etc., like that. Yeah. So then how we can go and run in your environment? So you can see that we can move to virtual environment, and then we can go and use the help command. So this is some sort of get method. This is some sort of post method. So let me quickly go and pull my Visual Studio. So here you can see the program, and I have added the program in the same folder. Now, one thing is there, while you go and run this program, so let me show you one thing here. If I go and remove these lines like import URL library and simply negate that certificate warning, then what will happen? If I go here 2.3a, first of all, let me do help. Let me show the help. So help is working fine. And here you can see that you can go, this is the argument parser output, right? You can see the help command will give you the what you want. Get the interfaces. So get interface will fetch all the interfaces, configure interface, configure an interface. We have option -h or help, right? I have this option or this option. Now let me show you this. If I go and do the get interfaces or something like that. Oh, I'm not getting the warning here. So you can see that it is clearly telling that you have certificate warning, right? But it is running the script. So what I'll do, I'll go here and remove this. And then let me go and save this. Now, if we go and run this, oh, still I'm getting some warnings here. And let me do one. Oops, no, I'm not getting. See. So here we have the program. So certificate warning gone. That's why we are using this. Apart from that, sometimes if you go and run this program, you will get some error related to certificates. So you can see I have created one small set of program here that you can go and run in your routers, like generate the crypto keys and enable IP HTTP server, enable REST configuration, and I have added all the client secure method, HTTP client secure. This is the authentication method with the server, just to negate the warnings that we can go and get related to TLS. Some certificate error you will get. And apart from that, I have installed the certificate, self-signed certificate as well within the router. If you go and use these commands, likely if any error will come, then you will first of all ignore it, and if any certificate error is there, you can go and create this self-signed certificate. Again, this is just for the lab environment that you can go and check, because in the production environments you will not get such type of errors because they are fully patched with all such type of vulnerabilities. All certificates and everything is there configured already. All right, so you can go and run this program. Likewise, you can run extra program. If you want to add anything, you can go and add all those things and delete all those things. Good job. Let's stop here. Good job. You have completed up to 2.3, where we are building the Python script with respect to REST APIs. Now, in this section, we have one more example related to consume and use a new type of REST API or new REST API given the documentation. Given the documentation means that we know that we have different type of APIs methods. So if you go and refer the document, you will understand that you have post method, you have get method, delete, and you have put method. Like different type of methods are there, and using those methods, can you go and create or build one script related to these REST API related to, for example, Cisco SD-WAN. So here I'm taking one example related to SD-WAN. You can take any example. So here you can see that we have the post method that will go do the authentication and will get the APIs keys, the tokens, the session cookies. Once you have that token, then you can go and get different or do different type of tasks like retrieve the devices, get the device ID. And once you have the device ID and template ID, then you can attach the template ID with the device ID. At the moment in my backend, I am connected with one of the SD-WAN lab, means my laptop where I am doing the recording. I can go and log into vManage. So I have the reachability to the vManage, SD-WAN vManage management plane or the server. And from this laptop, I will go and execute the script from my Visual Studio. So I will show you that script. Here you can see that you can go and set up the environment. You can install all the packages that we have discussed in our previous sections. Then we can go and build the application. So we will go and build one Python application related to SD-WAN. We know that on top we have the import statements. And if you want to ignore the warning, then you can go and use the URL library 3. And then even in the payload, you can make this verify as a false. So these two statement and this statement, any certificate error will be taken care. So first of all, what we want? We have one function where we want to authenticate and what we want to return. We want to return. So you can see the return is session, and session is nothing but your token. Your token, that means your uh, session ID, or you can say that you have your authentication value. So this token that you have, right? You can see this token, that session that we have, this token value we will go and use within other functions within the parameters, right? So first of all, we need that key. We need that token that we can go and use within other functions as well. So after authentication, you can see that we have the get device function. With get device function, what we are doing within that we have one URL, data service devices. With this data service devices, what will go? We can go and print the device list. So here you can see the response equal to sessions get URL verify. That's the certificate error. You don't want certificate error. URL and this. That means with this particular get API, we'll get the list of devices, right? And here you can see that this is JSecurity on top. With this particular post method, this is the post method. You can see that post method where we have the data as a payload. So the data that you have that you are using, obviously in the post method, you need the data. So here you can say that you have your payload, username and password, and certificate verification. Just ignore that certificate errors. So first function clearly using post method where we are getting some tokens where the payload is username and password. Using that session token, we can go and get the device list, right? And then you can see we have the get device list device details. So here you can see that we have the device and then the device ID. As per the device and device ID, you can get the device details. And suppose if you want to attach the device ID with a template ID, you should have the device ID and template ID. Then that particular device ID can be attached with a template ID. So here you can see that payload here, where you have the device ID, device ID, and template ID, and you can do the attachment. Now, if you know Cisco SD-WAN from vManage, you can go and create the device template, device feature template, and that device feature template you can attach with the devices, with the devices you want to attach with, right? So the process we have here defined where we have some post methods. So you can see that we have some post method, we have some get method related to our API calls. We have some, let's see, get method, and then you have the post method. So attachment, creating something new will be the post method, or updating the object will be the put method. Like that, we have the methods. And then finally, in the main function, what we are doing that we have that session, that's the authentication function that you are calling. So here you have the function authenticate that you have within the main function. Now this token is used within getting the devices list, and then you are printing as a JSON dump, and then you have the device ID. Again, this is one trick that you can get the first device. 0 is for first device and then the UUID. But I'm not doing the attachment of the device and with the template, because for that you should know that behind the scene how you are attaching the devices and template. This is just an example. I'm showing you the example that how things are working behind the scene. So now you can go and print what you can go and print. So you can print authentication successful, then you can go and print the get devices information, and then you can go and print the device detail. Like these type of details you can print. So obviously once you have the script, then you can go and start your environment and you want to run the application, and you will see the output will be look like this. So let me pull my script and let me run this. Here I have the script. You can see that we have this full-fledged script here. The script name is 2.4.py, and I will go and print what I want to print here. I want to print, in case if you want to print the session as well. So let me show you this, how this look like, this token session, just to show you. So I should print this just below this. Let me cut and paste this session here, and can do one thing. You can print the new line character as well. All right. Now let's go and run this script. So I can go to python.exe, and then what's the program name? 2.4.py, run this. Now since I have my device, you can see authentication successful. Let me show you that. So if I scroll up, getting all the device information and the output. Wow, good amount of output. Request the session object as this. So authentication successful, and this is the session, right, that we have. And then you can see the devices. First of all, you will get the key field and then the data field, key and data field. And then you have the list of, you can see the data. So list of the devices, and by the end, I don't want to attach the template with the device. So that's why I'm not attaching it. So you can see that how with the help of Python, we can go and create a script that will be followed by the given documentation, right? So we can consume new REST API as per the given document. And this is one of the nice example with respect to Cisco SD-WAN, but it is not limited to that. Same type of programming style can be used to anywhere. That's the main goal here to understand. All right, let's stop here. Good job, everyone. You have completed up to 2.4. In 2.5, we have to learn about the RESTCONF, NETCONF, and YANG model. So what I have done, I have taken one video from CCNA. In CCNA, we have one section 3.8 in CCNA DevNet, and then I have represented here. So please go watch that video after this short video, and then we are completing 2.5. Great job. You have completed to 3.7. In 3.8, actually this video is very important. So in 3.8, we have to understand the model-driven programming options that we have. We have YANG, RESTCONF, and NETCONF, and how we can go and utilize this in Cisco environment. Now, from our previous recordings and sessions, we know about the YANG, RESTCONF, and NETCONF. What's the use of these methods, right? So let's go in these methods. Let's try to understand these methods one by one. YANG models, this is the data modeling language, and these models will be used. Uh, Obviously, this model will be used, primarily it is used in NSO environment, but this model will be used to create configuration, to do some configuration, to do overall configuration management. And you can, with these model languages, you can push the configuration to multi-vendor environment. It's not only for Cisco environment, but it can be useful for other vendors as well, like F5, load balancers, firewalls, Cisco routers, switches, everywhere. These models can be used because most of the vendors, they are supporting this data modeling languages. So what's the step for YANG models? Identify the YANG model, find the appropriate YANG model. This is the modeling for the data. For configuration and operational data that we want in our infra, Cisco provides many standard and custom YANG modules. Understand the model and utilize it. Use the tool. Tools like Pyang can be used to validate and visualize the YANG model. So one of the example here, that suppose if you want to see the interfaces detail. Now this modeling language is very much simplified in a way that you will get the key and value pair. So for example, if you want to know about the interfaces and the parameters within the interfaces, so this is the model example for interface. And then you can see IETF parameter in XML, NS, YANG, IETF interfaces. So interfaces, obviously interfaces, list the interface. What are the key for the interface? Name, obviously interface name is gigabit Ethernet 00. So obviously that is a string. Type is a string. So here you can see key and value. Key is the name, value is the value that you'll go put in terms of a string. So this is the key and this is the value. Likewise, description. How you'll go and give the description? Description will be some string value, some characters, right? Then what's the status of that interface? It is Boolean. It is either up or down, true or false, right? So this is the condition for that. This is one of the example related to modeling the interfaces. Likewise, you may have anything like any type of configuration or sub configuration can be modeled, can be configured like this. And obviously I told you earlier that Cisco has good examples. They have good supports related to standard and custom YANG models. Next in the line, we have the RESTCONF. We know about the RESTCONF that will go and use the HTTP methods. We know about these methods like get, post, put, delete, and few of the lab examples we have performed earlier as well. related to RESTCONF. So interesting point here to understand is this, that first of all, you should go and enable this RESTCONF in the device. Otherwise, it will not work. So you have to go to your devices. Suppose iOS XE, I have iOS. XE device, I can go to the configuration mode and I should do IP HTTP secure server, and then I should go and enable the RESTCONF. If you go and enable, if you go and run these commands, then RESTCONF will get enabled. And then as a payload, here you can see as a payload, we may have the payloads related to send receive data in terms of XML JSON that can be used with help of the modeling languages, and we can configure that. So here you can see that we are using curl method to get some interface information. So that's the interface information. With the curl method, that will go and use the API method. That's the RESTCONF API method. And then we are getting the output like this. So interface name, the description, enable or disable or not, right? The same thing in terms of modeling. So you can see that we have the model where we want the interface description and the true or false value, like it's enable or not. So same modeling language can be used within the API, within the REST API, and then you can see the output, right? So kind of integration of your Yang models to the RESTCONF. Next in the line, we have the NETCONF. NETCONF is a networking management protocol that provides mechanism to install, manipulate, and delete the configuration of network devices. It uses XML encoded data. So data encoding is, data format is XML encoded, and it is running over SSH port number 830. So in the lab, I will show you that we are specifying port 830, and with help of that port number, it will go log into the device, and then you can go and install, manipulate, and delete the configurations, right? So for NetConf also, you have to go and enable the NetConf Yang. So you should go to conft in your router, and I have enabled this in my lab setup. So I should go here. So what I have done, I am enabling NetConf and then Yang. Data modeling language Yang that is integrated with NetConf. Likewise, you have seen earlier that we have the data modeling language Yang integrated with the RESTConf, right? So here we have the integration in terms of Yang modeling language for NetConf and NetConf. You can see important point here is this: establish a NetConf session, use a SSH client or library. That SSH client or a library that will go and connect to the devices is nothing but NC client. NC client, you should have this module installed in the Python library. Otherwise, it will not connect and create the NetConf session that I'm going to show you in my lab setup. Send netconf RPC, use remote procedure calls RPC to perform configuration changes and retrieve the data. Right. So let me quickly show you one example related to that. We have the NC client in my, I have done pip install NC client and importing the manager. Then connection to the devices storing as M. Here clearly you can see that port number is 830, right? So we are connecting to the device. Once we are connecting to the device, we are getting the configuration, the running configuration as XML. Once I have the configuration, then what I want to use the new configuration. In that new configuration, I want to change the description over gig Ethernet 2. So with this script, I will go and change the description for this particular interface, and this interface I'll go and make this as a configure by NetConf, right? So now you can see that payload. Now the same thing that we have discussed, same type of data format we have discussed in the YAML. So this is what? This is one of the example related to, see, model is different thing, and while you are pushing the payload is different thing. So model, you can get inspiration from the model, and then you can create your own code. So if you check this particular code, this interface XML UNI, ITF, XML, this entire code, and then interfaces. So let me go and show you the data model that we have. So the data model that we have, this namespace for interface, and then we have container for interface name and type, description, type, and the state, it's true or false. So enable state, true or false. So now we'll see here that as per the Yang modeling, we have the name, we have the interface, container interface. In that interface, we have the name. For that interface, we have description in the string format, right? It is in the string format, and then enable is true. And then we are closing the interface, we are closing the interface container, and we are closing the config. That is very much XML style. Whatever things you are opening, you are closing that. Right. So this way you can go and run the program. So let me quickly go to the Visual Studio code point that I have. Here you can see. So here you can see that we have the program for NC client and connecting to the device. This is my CSR router. Yeah, I'm using port number 830, username and password. And then I want to connect. So if I go here and if I have my Patti, let me quickly log into the device and let me show you first that what is the configuration over gig 2. So description configured by NETCONF. Already I have done some configuration here. And what about gig 3? If I go to gig 3, so it is not there, right? Nothing is there. So what I'll do here, I'll quickly go and change the interface name. Instead of interface gig 2, I will go and change the interface as gig 3. So here I'll go and make this gig 3, right? And then I will go and run this program. So let's go and run this program. So python.exe, and what's the name? 3.7. Let's run this. And while it's going on, let me go and open this interface. And if I go and check the interface, now you can see it is configured by NETCONF, right? And then you can see the output. This output is nothing but printing the config. You are printing the config in the XML format, right? That's a big output in XML format. And we are taking this particular config and we are putting this in the new config. So running config. So now you can see target is running, right? Target is running and the config is new interface config. So from this config, we are only changing the interface description. Enable is true. This is the modeling that we have. All right, although this is very interesting video, and if you need to watch this twice, you can go and watch this twice. You can create such type of programming and you can test the result as well. All right, let's just stop here. Good job, everyone. You have completed up to 2.5. In 2.6, we have to go and perform a lab task where we want to create a NETCONF filter by using XPath. Now, for NETCONF, obviously, we should go and do pip install for NC client. And with help of NETCONF XPath, we can go and retrieve the operational data from network devices, right? So XPath filter that will go and allow us to specify a precise part of configuration, right? So we want to retrieve something precise, we want to retrieve something, some operational data, we can go and use XPath. What are the steps here? The steps that you should go and install NC client first to set up the environment, and then we can go and prepare the NETCONF devices. So suppose I have iOS XE router and where I will go and run one command. That command is netconf yang. So go to the global configuration mode in the device and run this command netconf yang, right? So that means that your device is ready to take these configurations from netconf, and then we'll go and prepare the script. So here you can see that we have this script using the XPath filter, and how it is. First of all, we'll go and import the package NC client. Yeah, so from NC client import manager. This is the device credential. In your case, it may be different. In my case, I have one iOS 6 device. We know that NetConf is using port number 830, username and the password, and then the rest of the script related to XPath. So XPath filter for retrieving the interface detail. In this script, we want to get the interface details that will be in XML format. So here you can see the filter. The XPath filter is interface state, interface name is gigabit Ethernet 1. Now we'll go and define the function that we want to connect, right? So here is the function name, get interface detail with manager, connect to the device as M, and then sending the get request with the XPath filter. So now you can check the use. What's the use we have with the XPath filter? So now we have this M that we are connecting to the devices, right? And then get API. This is the method, not the API. You know that we have the methods defined for HTTP. We have methods defined for API, get, put, post, delete, etc. Right? So here we are using the get method, get request to retrieve the information of the interface, and then the filter. Clearly, you can see the filter, XPath, and XPath filter, right? And then the response is response.xml. So fairly straightforward script we have using XPath filter. We can go and retrieve the information. Finally, that we have the main function. In the main function, we'll go and print the interface details, right? Once you have the script, you can go and use the Python that you can go and run this script. So here you can see that we have the script, and then you can see the explanation, the device connection parameters. So we are using the NetConf port number 830 to connect with the device. Then we have XPath filter. XPath filter, we are specifying the gigabit Ethernet 1. This interface, we want the details in the XML format. Then we have NetConf manager that will go and establish the session. And then we have get config request, including the XPath filter, to get the interface information. So here you can see, once we go and run this script, the output will be like this. And let me quickly go and show you my script, and we'll go and run this script. So here you can see that I have my script here in Visual Studio, where the parameters, we have the XPath filter defined, and then we have the function. Within the function, we have the XPath filter, right? Where we want the information related to gigabit Ethernet 1. And then in the main function, we are calling the get interface details. So interface details equal to get interface details, and then print it. Now here you can see that we are printing in the form of XML. So return value for this function is response.xml, where we have the information about this particular interface. So let's go and run this 2.6 in my list. And once you are running this example, you will see the output, and you can see that we have output related to gigabit Ethernet 1 and all the details about that gigabit Ethernet 1. Now, if I can go and make this 2 and run this one more time. So this time you should see the information related to gigabit Ethernet 2, right? So this is the way that you can build a script and get some interface detail via the NetConf using the XPath filter. Good job, everyone. You have completed 2.6, where you have learned about XPath. In 2.7, we will go and build a lab with respect to NetConf RESTCONF and using the tool that is Yang tool. So what we want to do here exactly, let me show you that. Can we go and understand the Yang model, and understanding Yang model, can we go and create a set of examples, a related set of example with respect to NETCONF, RESTCONF that we are going to see here. So suppose if you have to build such type of lab, you need some prerequisite. You have some prerequisite, means you want to set the environment. To set the environment, we should have Python, NCC client. We know that this is for a NetConf, NC client, request for RESTCONF. RESTCONF means for to call those APIs. And we have used this request packages and NC client and Python. Everything is there in our lab. Everything is set. It's set there in our lab. So you can go and do pip install for NC client and request, one for NetConf, one for RESTCONF. Then we should have the devices, and those devices should have the basic configuration so they can understand the netconf Yang, they can understand the RESTCONF, username and password and basic configuration that we know from our previous section. Then related to Yang package, we should go and install pip install Yang. And if you want to see that Yang model, then this is the command that we can go and check the Yang model, that is the tree related to Yang model, right? So these are a few of the prerequisites we have. Then what we can do? We can go and build one of the example related to NetConf. So here you can see that we can go and set the device parameter. We know that NetConf is using well-known port number, port 830. We have username, password. So we have the device parameter set. Then we should have the payload. In this payload, what we want, we have the interface gigabit Ethernet 1, we have the description configured by NetConf, enable state is true. So like that, we have the parameters related to device, we have the NetConf payload. Now let's go and define one function, configure the interface. We want to configure the interface. First of all, we want to connect to the device. So we are connecting to the device as M, and then the response we are collecting. So connecting the device, the running target, and the config is the netconf payload. So what we are doing, that within the we are editing the running configuration. Target is the running configuration. So edit the config running and put these payload, that's the payload, that the interface gigabit Ethernet 1, the interface description is configured by the netconf, and then get the response, and then this response. So once you go to the main function, you can go and call this function within the main function, and it will return the response that will be that gigabit Ethernet description is configured by netconf. Easy, straightforward. But what we are doing, we are using the Yang model. Now same thing can be go and configure via RESTCONF as well. And you can see once you want to run the program, you have this Python netconf .py that you can run. Now RESTCONF is again little bit easier, and we know this thing that netconf is using data format XML. On other hand, RESTCONF will go and use HTTP method, and it will use data format JSON, which is very easy to read, and it is used like that. It is utilized at different places. So here you can go and import the packages, request for RESTCONF, JSON, and then the HTTP basics. That is again the authentication method. You can go and set the device parameter very much like we are setting the API, such API type of request. This is the URL where you can go and get or post any type of information. So getting the authentication credentials, and then you have the payload. What is there in the payload? Again, want to configure gigabit Ethernet 1, but this time with the RESTCONF. So once you have the basic parameters set, then again you can go and call these things within the response. So within the response, we are using one of the HTTP method, that is put. Put means update an object. So what we are doing, there you can see that we have the URL. We have the URL. What is that URL? For gigabit Ethernet 1. But here we are putting the payload. So here you can see the data. Input method, the data. Data is what? JSON dumps payload. And where is the payload? Here is the payload. What it will do? It will go and configure this particular interface with these parameters, right? And then finally you can go and print the status code, right? So put method will go and do the configuration, and now you can see that how we have the interaction with respect to RESTCONF, with respect to NETCONF, and we can do same set of things. Finally, you can go and print the output. First of all, you can execute the Python script, execute the Python script like this, and you will get the response. Once you have the response, that means we can store somewhere. Conclusion is this, that yeah, we can go and use the Yang analysis tools to understand and validate the Yang models, ensuring accurate configuration for of network elements. This approach provides a structured and automated way to manage the network configuration. All right, so we are very much good here. Let's stop. Great. So now we reach 2.8, where we have to learn about Ansible. And related to Ansible, you can see we have different type of subsections. So with Ansible, loop control, conditions, use of variables, templating. And finally, you can see 2.8.d, where we have to understand the use of connection, plugins such as network CLI, HTTP API, NetConf, etc. Right? So this particular subsection or section is going to be a big section, and that's why I want to split this section into different parts. So in first part, that is, we can see that is 2.8.1, we'll understand the loop control, and in this video we have to go and build our foundation as well. So first, if you have to go and work on labs, what you will do first? You will go and install the Ansible, right? Means you have to go and set up the environment. So once you have the environment, means once you have the Ansible installed in your system, then you can go and install, or you can go and create the Ansible role, and commands are there. Some commands are there that we'll understand. And then we'll go and create the playbooks. These playbooks are nothing but the task. So define task in the role. So first you go and set the environment, create the Ansible role, and define the task in the role. So different type of playbooks will do different type of works. And finally, we should do the documentation as well. So when you want to set up your environment, you can go and do sudo apt update, install Ansible, and then you can go and create your project directory. In that directory, if you go and run this command, Ansible Galaxy init nexus role, this is the name of the folder, it will go and create one folder, and within this folder, you will see so many different type of subfolders. Right. So here you can see that it will go and create the defaults, filters, meta, task, templates, etc. One by one, you can go and utilize these particular folders. So suppose I want to create one playbook. In that playbook, I want to configure VLAN for Nexus switch. And then for those VLANs, I want to configure some tasks like, switch port mode, switch port access VLAN 1020. The VLAN name will be web app DB, etc., etc. So those type of things that we can go and create within the task and the main function. But in Ansible, while creating different type of playbooks, we have options. We have options that we should go and define the variable within the program itself. So I can call the variables from outside. That will be my external variables. Or within the program itself, I can go and define the variables. Or I can locally put the values for the variables. So all options we have. Right. So here you can see that step 4, create a playbook to use the role. So you have the role here. Actually, these are the external variables that we may define. And then obviously when you want to run the playbook, you have to give the inventory as well. So here you can see that we have one inventory file where I have one host, username, password with respect to this particular file. I want to run the program, and I have external variable file as well, where I have external variable defined as VLAN 30, ID is 30, name is DB, like that. So point here is this, like other programs that those are working like that, here also you have all those parameters, right? You have all those functions, so you can define the variable locally, or you can import from somewhere outside within the same folder, for example, external vars. Once we go and call this within the main program, it will go and call this particular external variable and put the values. So what will happen? Suppose I have one Nexus switch, right? Nexus switch. Suppose I have this Nexus switch 1.10. In this Nexus switch, I want to create three VLANs, VLAN 10, 20, 30. And after that, on those VLANs, I want to go and assign IP addresses. So if you have three VLANs, if you assign two IP addresses to three VLANs, so that means you are going to create some sort of looping condition, right? One, iteration two, iteration three, like that. You can create the conditions as well, like looping as well. And that's the agenda for this particular section, that we should create a program in a looped function. I will show you that. I will show you after one or two slides that how our program look likes and how we can define, and we can even execute as well. Everything I'm going to show you. Now, finally, you can go and create the supported document in the MD file. This is very much like when we are using GitHub, then we are creating such type of files as well. So in this file, it is defined what is VLAN, why we are defining the VLANs, what is within the playbook, and all those things. Finally, we want to run this playbook. To run this playbook, you should refer the inventory and your program. I'll show you that. I will show you this in our lab, how we'll go and run the playbook. So in our lab, we are going to execute two lab. One is basic lab, one is the loop lab. In basic lab, we'll go and create VLAN 10, 20, 30. So this is the parameter for basic lab, external variable. So I have one external variable file for basic lab. And here you can see that I have VLAN 30. Then we'll go and perform one task related to loop. For that loop, we can see this is my external variable where I have VLAN 10, web, and IP and mask, like four terms or four things defining that. And then you can see item 1, item 2, item 3, VLAN 10, VLAN 20, VLAN 30. We'll go and do that. Now, what about the lab example? Here you can see the lab example. Again, this is very much straightforward. So first of all, you will go and define the name of playbook. So what we want to do here, it is defined here, execute the task on all the host here, host all, defining the inventory file. So this is the name, execute the task, because you have to go and do the task. You can see I have task. What I want to do, my task, create a VLAN. See, this VLAN, we are giving the ID. We are giving the ID locally. So I want to create VLAN 10 with this name, and transport I am using NX API. You know that we have one feature NX API within the Nexus switches. If we enable this feature, then it will take some HTTP calls. So NX API, feature NX API, you need to go and enable in the Nexus switch. So that is already enabled in my lab infra. So this VLAN we are creating like manually. Then I want to create VLAN 20. So here you can see that next I want to create VLAN 20. First, I'm checking it is there or not. Then I want to create it VLAN 20.id. From where it will come? It will come from here. VLAN 20.id means 20. VLAN 20.name means app. So VLAN 20.name means app. So this is manually, this is calling from this variable here. And then VLAN 30, we are creating from outside variable. Outside variable means this. If you see this external var file, right? External var file. We have external var file. This is my external var file where I have VLAN 30. ID is 30, name is DB, web app and DB, like that, three VLANs we're creating. And then you can go and execute it. While executing, what you will do Ansible playbook, and then you can run that playbook. Let me quickly show you the example first here, and then I will run that playbook. So here you can see that I have created all the documents for you. So while you're watching this video, you have access to these documents as well. And then here you can see that variables. In one lab, I have only this much of variable. In other lab, I have this much of variable. This is my variable file. Then the inventory. In my case, I have this NXOS version 1, my inventory, and all variables, all vars. And then the configure the, create the VLAN. So this is the program we are going to refer first. So this program, I will go and execute. What will happen after executing this program? It will go and create the VLAN 10, 20, 30. So let me pull my automation server. Here you can see that I have my automation server, and if I show you the inventory, you can see that is my inventory. And then if I go and run the playbook, so Ansible playbook, and then what is that name of the program? Create VLAN YAML, and then the switch is I is inventory. Run this. So now it is running, it is checking that it is there, not. If it is not there, it will go and create it. Otherwise, it will check that, oh, it is already there, already there, already there. So you can go and check this. So I can go and connect to my NXOS system. Let me try to log in, show VLAN. So now what it will do, it will go and create VLAN 10, 20, 30, right? So that is one of the program we have. Let's go and quickly check the program number 2, where we have the loop condition. So what we want now, that with those VLANs, we want to assign the IP address. So on top, you can see that we have the name of the playbook, host all, and then you can see that this is the variable. Now this time variable is, where is my external? This time variable is this, VLAN 10, 20, 30, and these IP addresses. Then task. What is the task? Item dot name, right? Item name, item dot description. So item name, item description, state. So this is the task that we want to do. And here you can see that we have the condition. So here we have the condition that it will go and create the VLAN. So this will go and create the interface VLAN 10, 20, 30, right? And then the description, right? Interface VLAN and then the description. It will go and create those. So if you go and check the VLAN interfaces here, so within the VLAN interfaces, so you can see that this is assigning the IP addresses, external. So this is your external var YAML file. This is the file that we are calling. Then we have the name, description, and IP. So then you can see the name, description, again the name, IP, mask, transport is this, VLAN interfaces. So from VLAN interfaces, you will go and in first condition, this is the first loop, right? This is the first loop. We'll go and check the interface description. State is up, like interface description. Then in the second task, actually the same task, the second part, that assigning the IP address to the VLAN, right? So then we'll go and assign the IP addresses. So in one task, you have two tasks, that admin of the VLAN interfaces and assigning the IP address. And it's very easy and straightforward with the looping condition that you can go and achieve this particular task. So why not check this? Let me go here and lab 3, 3 dot loops. And let me quickly show you the inventory, the external, here you can see, and inventory, the variable and the inventory here with the inventory as well. Now, what we can do here that we can go and run that, right? So Ansible playbook, or that task that we want to do, we want to create something, config the VLAN interface, right? And from the inventory. All right, so with this IP, it is working fine. And if I go here, to IP interface brief, okay, it's not connected anywhere. That's why the link is down. But yeah, it got good job, everyone. You have completed up to 2.7, where we have understood about the loops and the rest of the topics that we have to understand related to Ansible infra and the documentation. The last video was like almost like 15 minutes. So what I am going to do that this video, I will cut it a little bit short because anyways, we know all the documentation part and rest of the things. Here in this video, what we need to understand is one program related to Ansible conditions. How we can go and put the conditions in our program. Now we know that we have one inventory file. So I have one inventory file there. I have one of the Nexus switch for which I want to run the condition lab related to Ansible. What I want to configure the VLAN 10 over these interfaces. You can see interface 1, Ethernet 1/1 up to 1.5, VLAN 10 from 6 to 10, VLAN 20, from 11 to 15, VLAN 30. In our previous sections, we already created the VLAN. Last video, we have created the VLAN and we have assigned some IP address as well over the SBI. So what we will do that in this section with the loop and condition, we will go and set the instruction. First of all, we'll go and assign the VLAN to the interfaces like this, and we'll go and put some description as well. So here you can see that playbook for setting the interface description. This is that we are starting the program. Our external variable file. So this is our external variable file that we are going to call within the task. So once we go and start the playbook, we have the task. We're defining the task as says the physical port description for web interfaces. Then for app and DB, we have 3 category here for the applications, web, app, and DB. And with the conditions, so here you can see that we have the conditions. So here you can see that we have the interface name web. The description is web VLAN. Transport is NX API. And we are using one loop. So with items, physical interfaces, only when the VLAN value for each of the items defined is 10. So physical interfaces, the condition. So here you can see the condition. So physical interfaces, the condition is that when we have the VLAN number that is 10. So when we have the VLAN number 10, that means we are talking about interfaces number 1/1 up to 1/5, right? So this is for that physical interfaces. Right, and then those physical interfaces, what description we are putting? We are putting the description that is a web VLAN, correct? Web VLAN. Now, once you have this type of condition, you can see that the rest of the program are almost the same. So here we have the loop, we have the condition. So with items, so interfaces 1/6 up to 1/10, we are matching this condition. And what we are putting the description as a app VLAN. For interfaces 1/11 up to 1/16, rest 5 interfaces, we have the interface VLAN name, that's the VLAN 30, the ID is 30, name actually. So name is web app and DB, that we know that we have those name, web app and DB. You can see that description will go We'll go and put the name and we'll go and put the description until the loop end. Easy and straightforward, right? So why not, let's go here to the lab section and pull the server and do this configuration. Let me quickly go and connect to my Nexus that if I can put the correct password or my lab is connected. If we go and check show run for interface E1/1, you can see it's 1/2. So we have the interfaces, but these interfaces, they are not defined, means the VLANs are not assigned here. Now, if I go here to my program and if I go and check the inventory, if I go and check the variable, so inventory, you can see that we have Nexus 1. Here you can see that is the external variable. And finally, if you go and check the, what we have, the file set interface description. So here we have the program, right? So now what we will do, let's go and run this program. So we can go to Ansible playbook and then for inventory and what's that program? Set the interfaces. Set the interface description. So it is detecting VLAN 10 as per the condition 1/1, 1/2, 1/2. And then I can see that it is trying to set the port description. So if you go here and you can see the port description, if I go here, oops, still it is on the way. So you can see up to 1.1, 1/1 up to 1.5. This is web. And then you can see that, oops, app, and then you can see the DB, right? So you can see that our run is completed and our task is completed. All right, so let's stop this video. We have completed the lab task here and now we can go and stop it. Good job, everyone. You have completed up to 2.8.b. In 2.8.c, we have to understand the uses of variables and templates within the Ansible script. What we are going to do here is that we'll go and use a template. So what will happen is that suppose if you're not using a template, then once you go and run the script, once you go and run the Ansible script. So for example, I have this script that when I go and run, it will go and fetch the information related to interface VLAN 10, and the output will be very much like in JSON format, and it will be JSON dumped. That means that in this output, I have everything. I have everything related to the interfaces, and also you can see that I have my inventory. And then when I go and run this script, so let me quickly go and run this script and let's see the output. So what will happen, you know that this is the playbook we have and the task we want to execute here related to the show IP interface VLAN 10. But here you can see that the local action that we have, that the copy content that we have for interface facts, the destination I am storing. So my file will be, the name of my file will be interface and then the name of the host name, that is nxos1.json. So let's run this playbook and see the output, and then further we'll discuss more about the template. So let me pull my server. Here I have my server. And if I go and run the Ansible, let me see what scripts I have. So I want to run my Ansible playbook, and that is related to get the output in YAML format and then the inventory. Let's run this. So while I'm running this, you can see change is there. And if you go and check the file, so ls minus la, that the file that we executed, and we should go and see this particular file, right? You can see when it got created. So you can see that we have the output, but we have output in the dump. This is JSON dump format. Now, what we can do with the template, that such type of outputs that we are getting, we can go and do some edits in that. Edits means that suppose if you want the output in this format, like, suppose this is your format and in this format you want the output. So what you can do, you can go and create one template. So you can see that I have one interface template example related to Jinja 2, where I want the output in terms of, I just wanted the interface prefix subnet and mask, and then the result for that, which is a storing within the fmt.int, right? fmt.int will give you the prefix, subnet, and mask. So here you have the example with template that you want to run a new playbook where you want the output for show IP interface, and the interface is a local variable. It will be pulled from here. And then what we want to set the fact that we want to go and read the top of the table, right? Top of the table that is there in the fmt underscore interface. And then you can see that we are defining the template. So here we have the template. Here we have the template. You can see that create a new file using interface underscore template.j2. So this is our template, right? Template. And this template is working as a source, right? Working as a source. So use this template and your destination output will be inventory hostname.txt. So that will be your inventory output that you want to go and print in this format. So let me go and pull my server and let's run this program. So let's go and run that script that we have related to that output format that we want to execute. So Ansible playbook, and my script is interface template.yaml. I want to run with respect to the inventory that we have. Once we go and run this program, you can see that we have the set facts, we have the template, and we have the result. So let's see. So result should be stored in this text file, right? Because this is the output. And if you go and check this text file, here you can see that we have the output in this format. So that's the use of template, that we can pass that uh, script. Like we can read that script, and once you go through that script, you can see that template source is this format, this Jinja format, and destination we are storing those fields and putting within the text file, and then we can go and check that. All right, let's stop here. Good job, everyone. You have completed up to 2.8c. In 2.8d, we have to understand the same thing that we are doing from in our previous videos, same thing. But we have to understand some more plugins such as Network CLI, HTTP API, and NetConf. Now, from our previous learning, we know about HTTP API. This is very much RESTCONF based API, very much like the HTTP post, put, get, delete methods are working. This is very much like a REST API. And NetConf, we know that is using well-known port number 830 to do the configuration, and network CLI is just the CLI way to do the configuration. So we have CLI way, we have the HTTP type of method, and then we have the NetConf method as well, right? So knowing these things is how we can go and do the various tasks in Ansible. The starting will be the same, that how you're creating your environment, setting the variables. So those things will be the same, create the project and all. Right, and you can run the Ansible Galaxy init network devices. So it will go and create the project. And then one by one, you can go and utilize these methods. So for example, if I have to go and use the network CLI, I can see that I'm using the plugin network CLI to configure iOS line items. So line items are IP address. This is the address, no shutdown, and over this interface. And what is the connection type? Connection type is network CLI. Then we can go and define different variables at different places. The platform is Cisco, version is iOS. Now the way, so again, you can see that you have the project and you can have the playbook, how you can go and run the playbook. You know that the example for that. So here you have the final playbook example that we have network devices. Then we are defining the variables like Ansible connection, network OS, username, password, right? Those things. And then you can have your inventory, you can run the playbook. Normal, straightforward, that we are doing, that we have done actually in our previous sections. But next we have to learn about the HTTP API and NetConf. With these methods also we have to do the same thing. These plugins, we have to do the same thing, but the way we are doing the connection is different. HTTP API is very much like RESTful API type methodology, right? Means that it will use the REST methods to do the configuration, but you can see the example here related to playbook is almost the same, but the Ansible connection is HTTP API. So here in this playbook, here also we want to configure the IP address over the interface gigabit Ethernet 1, and then rest of the things are same, right? Things will not change. Either it's HTTP API method or it is NetConf method, because NetConf will go and use port number 830. So you can see that connection is NetConf, the connection is NetConf, and with NetConf also you can go and configure the devices. So either it's a network CLI or it's a HTTP API NetConf. The task you want to do is the same, but the way they will do the configuration is different. We know the differences, the basic differences in between RESTConf and NetConf, right? A RESTConf will use RESTful APIs. NetConf is a different way to do the configuration with different port number. And network CLI, that means directly you are logging to the devices and pushing the configuration, right? So the way we want to use these methods, their methodology is different, but the task that we want to do is to do the configuration related to one of the interface. Now it depends. Now these different option, they will give us the flexibility, right? So suppose if I am developing my automation infrastructure with respect to HTTPI method or HTTP API methods or RESTConf, then why not I will go and use the HTTP API methods all the places in all the automation script. Likewise, if I am developing my script with respect to NetConf, I can go and utilize the same. So in this type of setup will allow us scalability and maintainability for network devices using the Ansible tools, right? Okay, so this was the last video in this particular section, in Ansible section. Let's stop here. Good job, everyone. You have completed 2.8. In section 2.9, we have to learn, understand about Terraform. Within Terraform, we should know these things as per the requirement, as per the agenda. So we should know that loop control, resource graph, uses of variables, resource retrieval, resource provisioning, and management of a state of provisioned resources. These are the topics that we have to learn, understand in this particular section. So what we'll do as we are doing, that will go one by one. So let's go and focus on 2.9.1, that is the loop control. But a point here is this, that we should know that Terraform, that is going to be utilized to manage the infrastructure. Terraform is one of the infra as a code type of language that is developed by HashiCorp, and the language used very much similar to JSON, but language is HCL, HashiCorp configuration language. And once you go and see that examples and lab, you'll see that it's like a JSON type of language, which is very structured, error-free, and it's easy to learn, understand, right? So first step, suppose if you have to go and learn this technology, obviously you should have this environment up and ready working in your automation server. So first of all, I will go and install the Terraform. You can see the link here. In this link, you may get 3-4 commands that you can go and install to your server. I will show you those steps that how you can go and make your environment running or how you can install the Terraform within your system. Then you need some providers. In our case, I will go and show you example related to Cisco ACI. Even in the DevNet blueprint as well, you should know how to manage ACI network with Terraform. So that is the agenda, within the agenda. Then we will go and initialize the Terraform. We should go and check the variables and providers. So here you can see that we can go and define the variable, my URL, my username, my password. That is one of the file, variable.tf. So later on when I will show you the example, you'll see that Terraform extension is t.f. So any file name and that .tf, and then you can manage your file. So here you can see provider.tf, where provider is ACI. I will show you in our case, Cisco ACI, what will be the exact provider. But this way we can go and define the provider. And once you have the provider, once you have the variables, then you can go and build your main file. How your main file will look like, I will show you that main file as well. Once you have all the script ready, then you can go and apply the Terraform. So 3 commands are there: Terraform init, initialization or init init, Terraform plan, and Terraform apply. Once you apply that, obviously those things will be configured to the devices, right? And then the cleanup job, if you want to destroy the entire management, then you can go and use Terraform destroy. So here you will see that very small commands, like, right, very small commands, and then they are doing lot of work. We have one example here. I'm going to show you this example that will go and define the variable, and then we'll go and define the main file. So within the main file, you will see that we have the provider configuration, although I can have separate provider configuration as well. So first of all, what I will try to do that I'll create provider.tf separately in the lab example that I'm going to show you. And then rest of the configuration will be the same. So we'll go and define the variables. So I have variables within SEI. We have tenants, VRF, and uh, different types of attributes or different types of terminologies. You can see that you have endpoint groups, you have application profiles, you have service graphs and all those things. So point here is this, that in this example, I want to create tenant. Within tenant, those tenants I want to assign with VRFs like that. So I should have the definition for tenants. I want to create tenant 1 and tenant 2. And then I should go and define the variable VRF. I want to create VRF1 and VRF2. So then I have this create tenant and create VRF modules. So create the tenant. Yes, I want to create the tenants. And here you can see the loop. Here we are using the for loop as per the agenda 2.9a. That is the loop condition we should know. So in the variable definition, how many tenants I have? 2, right? So if I go and run the loop, it will go and create tenant 1, tenant 2, and then the loop will stop. Likewise, how many VRFs we have? We have VRF1 and VRF2, VRF1 and VRF2. So if I go and create the VRF, I'm using this variable called VRF here. So within the resources ACI VRF, I am using the VRF, and then I am using the loop. So I don't have condition here related to for each, but yeah, what I will do that within one tenant 1. The tenant 1 is what? Tenant ONE1, not 1. So within tenant 1 that I have ACI tenant example tenant 1, I will go and assign both the VRFs, right? So VRF1 and VRF2 will be part of the tenant, right? A very easy, straightforward example, you can see that creation of tenants, creation of VRFs, that's it. So define the variables and create it. Right, so defining the variables and creation of that tenants. Let me quickly show you the script that I have here. So I have copied those script to my automation server. So let me go and show you this. First of all, say provider TF. So here you can see that I have provider and the var and the username password and the URL, right? Then I can show you the variables. So here you can see the variables, username, password, and the URL. So provider, what provider? Yeah, ACI. Provider ACI calling the username. So actually from variables, I'm calling the username, password, right? Like this. And if I go back just to show you one more time, variables, so you can see that user, USER, PALS, and ACI URL. That's good. Now let's see the main file that we have, main.tf. So here you can see that I have defined the provider, that is Cisco DevNet / ACI. And then you can see the tenants, same function, same example that we have seen earlier. So then you will see the variable VRF, and then defining the variable, and then creation of those. So what we can do, now we can go and run this program. So let me go and run this program. I can go and use Terraform help just to show you that Terraform is not installed here, right? So I have this Terraform installation text here. You can see I can go and use those text to install Terraform within my system. So let me try to install it. Username and the password. So installing the Terraform, then I have to do this. So once it is done, then I will go and add this, and then finally I should go and install the Terraform. So these three commands are there to install Terraform within my environment. So Terraform got installed. I can go and check Terraform help. Now you can see that we have the Terraform, right? So what we want to do here, the commands are simple. You do Terraform init, INIT, and now it is finding the packages, and it has the lock.hcl. HCL is nothing, a HashiCorp configuration language. Terraform has created a log file. So it has created the log file. Initiation is successful. Then I can go and do the Terraform plan, right? And then apply. So let's do that. It's asking about the password. So let me give the password. Oops, password is correct. Yeah, so it is telling that, yeah, you can see all the changes here. Tenant one will be created and this and all those things. Right, now before going any further, I just want to SSH to my Epic, my ACI manager, and I have the simulator running, and that IP address is 198.168.133.200. Let me put the password and let me see, show tenant. You can see I don't have the tenant 1, tenant 2, and if I do show VRF, so let me exit from here, and now I will do Terraform apply. Right, Terraform apply, and let me give the password. Yes. So now you can see that tenant 1, tenant 2 is creation is happening, and the VRFs is happening. Now, if I go and log in, and if I do show tenant, I can see tenant 1 and tenant 2. And if I do show VRF, you can see that tenant 1 having VRF 1, tenant 1 having VRF2, means both the tenant, actually we are assigning the uh, different VRF to both the tenants as per our programming logic. So this is a way that we can go and execute the program. All right, let's begin 2.9b. In 2.9b, we have to understand about a resource graph. One of the nice feature we have within the Terraform, with help of resource graph in Terraform, we have the visible representation of the dependencies and relationship, right? So what we'll do that we'll go and complete one task. And if you want to see the visual presentation of the resources, the connections, that we can go and use such features that we have in the in the Terraform. For that, we should have the grep application that is running in our system. With that, we can go and convert the dependencies into different formats such as PNG, such as PDF, etc. Later on, we can go and see those things. So here you can see that we can initialize our function, the Terraform. Then we can create a graph. To create that graph, we have option Terraform graph, graph dot, and then that dot we can convert into PNG, into PDF, or any other graphical format that we have the graph viz. Now we have one lab example that we have done in our previous session. Same lab task, why not we can go and check that. So again, we'll do the same steps. So we have our variables, providers, and main functions. We can go and initialize the Terraform. Then we'll use the graph functions that we have in Terraform, Terraform graph, graph dot, and then we should go and check that. So what I will do that I'll go and install the function that we have, that is nothing but you can see that we have the graph, which I will go and install in my automation server, like you can go and install in your working environment. And then finally you can run this particular command. So you will get the PNG file. Once we have the PNG file, then what I will do, I will connect my automation server with WinSCP because I'm running everything in my Windows server. So I can show you that graph. So I will run that uh, WinSCP in my Windows. I will copy this file in my local Windows system, and then I will show you that how this graph look like, how this PNG file that finally will get how it look like. So yes, this particular function will give you flowchart type of or the graph type of picture where you can go and check the interdependency. Although in our example that we have very small type of example, the lab is very small. So when I'll go and convert it, you will see that only a small graph will get generated. But irrespective of what's the size of program, you can go and generate the graph and you can see it. So let's go to the automation server that we have. Let me pull that. Okay, let me exit from here. Already we have that Terraform and all those functions up and running that we have done. I haven't done the destroy. So if you watch that last session, you know that we can go and do init plan and apply, and you can see that we have tenant 1 and tenant 2. So everything is there. Here what I have to do, that I need to convert that into the graphical format. And let me go and install the grep which, that is which function, right? And let me install it. So now I have the grep which function. Now what I can do, that I can go and run that Terraform graph commands. So once this will get completed, you can see so many dependencies are there that is installed. Out of 82, 30 files, now 74, and it's almost done. So once it is done, then let me go and run the Terraform command, Terraform graph, and then I'll redirect that towards the graph dot. So you can see the Terraform graph, and then that is graph dot, right? And then we have the dot function, so PNG, and then the graph dot. That is graph.png, should be png. Let me see. All right. So now if I see here, you can see that I have the graph.png. Let me go and pull this within my WinSCP server. So let me try to connect with this particular server with my WinSCP server. Unable to connect here. Okay. Okay. And new session. Let me connect to the automation server that we have. That IP is .50. Username and password is little bit slow. Let me try to connect. It is connecting. Once it got connect, then I will go and so here you can see that graph PNG is there and dot is also there. Let me go to the folder where I have my CCIE DevNet. Okay. Let me go and put this graph here. Let me go and open that file. So here file we have, and you have the representation here. You can see that we have the ACI TNet example is connected with ACI VRF example, right? So this way we can go and generate the graph. Good job. Let's stop here. Good job, everyone. Now we are in the continuation of understanding the Terraform programming structure. In 2.9c, we have to understand the variables that already we know. In our section 2.9a in loop control, we have discussed about defining the variables, and with those variables, you can go and do the provisioning. We have different type of variables such as a string, number, list, bool, map, etc. And then we can go and give the descriptions. There are default values as well. And we have validation parameter as well, custom rules to validate the input. Here you can see our example that we have worked earlier, that we can go and define variable URL, variable username, variable password, variable tenant, like this, variable VRFs like this, right? So this is the example related to defining the variables. You can go and define the variables. Why? Because once you have variable, then you can reuse those variables within the code. The meaning of variable itself is this, the reusability. So it will give you the reusability, flexibility within the programming language, that you can call the variables one place to other place like that. Here you can see that we can go and define the provider. You can see that we have the resources, This is just an example. Already we have done one lab in our first section, that 2.9a, where we have seen the example related to that defining the variable, and then we have created tenant1 and tenant2, and we have created the variables vrf1 and vrf2 as well. Once you have those variables defined, once your program is there, you can go and simply use Terraform apply. Or if you want to run that in a single line with all the variables, then you can use this long string. Terraform apply, the variable that we have defined as a URL, the variable that we have defined as a username, the variable that we have defined as a password, and then it will execute the program in single shot. Otherwise, if you go and apply Terraform apply, it will work, but then it will ask you that what's the username, what's the password, that we have done in the earlier section. In our main program, we have the provider. So what I have done, that I have separated the provider, I have separated the variable. So we have providers.terraform file separately. We have variables.tf file. बोलना नहीं चाहिए था. Oh, great. You have completed up to 2.9b. Now in 2.9c, we have to understand that use of variables in Terraform. Why we are using variables? If you use variables, then you can reuse those variables at different functions, different calls. Variables means that that is not fixed, that can be utilized, and they are working as a placeholder. So you can reuse those variables, you can define somewhere, and again and again you can use it within the programming code. If you use the variables, then it will provide you some nice features such as the scalability, the generalization of the program, the modularity of the program. So these are the benefits that we have when we are using the variables within the code. Obviously, it will provide you flexibility. So your program, that a small piece of code, since you are using the variables more and more, so that a small piece of general code or module will be utilized at different places. We know that from our programming knowledge, we know this thing that we have n number of variables that we can define. In Terraform, we have examples related to string, number, bool, list, map, etc. And these variables, good thing about Terraform is this, that we can go and give human readable description as well. We have the default parameters as well for the variables, and validations function is also there. Now here is one example. We have done this lab earlier in our previous section. We have done this. So we have defined the variables related to URL, username, password. Then you can go and define the variables related to tnet and VRF. And we have executed this program where we have created tnet1, tnet2, and then we have created VRF1 and VRF2. So since we have the variables defined, then we can go and create a module to deploy these variables or use these variables placeholders to do the actual execution of the program that we have seen. That again, with these variables, so we have the variables.tf file, we have the providers.tf file. We can use these variables and then we can run our main.tf program where we can call the providers, where we can call the variables, and then we can implement that code within the infrastructure. Now here is one example, that suppose if you want to use Terraform apply, means you want to run your program, but with the variables, so you can give the strings related to variables. So here you can see that I can go and give variable, the URL variable, the username variable, the password, right? And then this program will be done. Here we have the example related to main.tf that already we have done with one of the loop example, loop control example, that I want to go and create tnet1 and tnet2. And here you can see that you can go and use the variables within that. So with respect to the previous section that we have done, you have the example in the similar fashion in the same line, where you can go and check the variable definitions as well. So we have created the variables related to the inputs, related to the constraint that we want to create, or related to the components that we want to create within the ACI infra. If we are using the variables, then we have the flexibility, the reusability, separation of concerns. That means the keep configuration data separate from the main infrastructure code, making it easier to manage and understand. And security also, that is also very interesting thing, that make sensitive variables, that's the password, to avoid the displaying them into the log. So you can see that it will provide you flexibility, reusability, separation of concerns, and security as well. Use those variables wisely, and then your code will be efficient, secure, flexible, modular enough that you can reutilize it. All right, since we have already done the lab in the previous section, so we are good to stop this video here. Let us continue our study, and in 2.9D, we have to understand about the resource retrieval. Already this thing is also covered in section 1, but I haven't explained you that, okay, you can go and define the variables, you can go and define different types of Terraform copies, but those different type of Terraform configurations or copies, you can call within the main functions. So we have different type of sets of Terraform file. So for example, if I can go and draw here, so if you remember it, we have one file related to variables.tf, one was providers.tf, and one was main.tf. So in these files that we have, different files that we have, say variables.tf, then suppose we have provider.tf or providers.tf, and then finally suppose if we have main.tf, main Terraform file tf. So point here is this, that when we are doing this resource retrieval, what exactly we are doing, that we can go and get the information. So these variables we can call within the providers we can call from within the main. So we have different files, different resources, different Terraform configurations, maybe within that folder, maybe outside of Terraform, that we can go and retrieve. That's the whole idea behind this resource retrieval, that we can go and retrieve within our Terraform function. And that's the example we have here. So we may have different data sources that we can go and create at different locations, such as variables.tf. So you can see that we can go and define the providers, the data sources we have in one of the file related to the login credential for ACI, the construct or the components that we want to create within the ACI, such as the tenant and VRF. So we have different type of data sources, and those data sources can be retrieved within the main function. So we can go to the main.tf, and then you can see that we have the provided information, we have the variable information that we are calling. Somewhere you have your variable file, and then you can go and use, say, var.username, var.password, and then not only that, then you have the var.vrf. Not only that, you can go and use the tenant as well, and you can run some sort of conditions, some sort of loop, and then you can call everything within the main function. That means the calling the resources or retrieving the resources from different files, different locations, to the same place. And once you have all those file, means once you have your main function created, then you can go and use the Terraform init, then Terraform plan and apply, and you can execute that Terraform program. Right. So like that, you can structure your Terraform programming, different resources at different places, but you can connect all together. So that's where the integration part will come into the benefits area of the Terraform, that we can integrate Terraform with the existing infrastructure by retrieving and using the data from existing resources. Then it will provide you consistency. Why? Because this will ensure configurations are consistent within the existing resource without needing manual input. Automation is possible because once you go and run that Terraform file, it will go and check the consistency of the configuration and all the packages and parameters, and then it will execute the program. Flexibility is there, yes. Allow more flexibility because we have the dynamic configuration and we have the real-time check and real-time execution of the programs as well. Okay, so these are the benefits that is implicit within the Terraform, that you should go and create the program like that. It doesn't mean that you can't go and create one main file, main.tf, and you can define the variables provided and all the input in one file. It is there, it is possible. But it's good that you create separate type of variable files, separate type of providers file, and then all those files you can go and call within the main function. So this will give you more flexibility in Terraform. Good job, everyone. You are doing great. Now in 2.9e, we have to understand about the resource provisioning. Now, resource provisioning, that you have multiple resources and how you can go and utilize these different resources in your ACI infrastructure to complete the task. And we have some complex resources as well, such as networking components, service graphs, such as BDs, such as endpoint groups, and you can see some simple one construct as well, such as tenants and VRF that we have seen earlier. But when you go and create the relational integration, you can see that suppose you have endpoint A, endpoint B, and in between endpoint A and endpoint B, you have some service graph, you have some security appliances, and then you want to redirect the traffic towards your L4, L7 services, and then it will reach to destination and vice versa. So in case of simple provisioning, it's easy that you have multiple files and you can work around this multiple files and you can get the result. But in case you have complex resources provisioning, in that case, you have to integrate your Terraform configuration in a way that you should have the complete project. So what I'm talking here is this. Let me quickly show you one of the complex example related to resource provisioning within the ACI. Here you can see that I have one full-fledged ACI deployment that I want to do. In that ACI deployment, I want to create EPG. Within EPG, I have some endpoints. I want to do VMM integration, means ACI integration with VM manager. Then what I want to create L4 to L7 services. I want to redirect the traffic. So I have application groups such as web app DB. I want to redirect the traffic from outside to web via firewall, and within the application movement within the app to web to DB. Also, I have some firewalls. I want to redirect the traffic. I have whole scenarios. I have full-fledged scenario, and everything I want to deploy provision from my Terraform. So here you can see the example here that you have. Let me start with this variable. So you can see that you can go and define the variables related to VMM, domain, controllers, VMS, tenant, L3 out, means you want to communicate to outside L3 out, EPGs, VRF, failover BDs, you have bridge domains, subnets, service bridge domains, subnets. You can see long list of variables you are creating, right? Once you have this long list of variables, then you have variables related to filters, means in between the EPGs, what type of access or uh, access or deny or blocking you want to create. So these are nothing but the access list in between different type of EPGs like web to app, app to DB, DB to other side, like DB to going revert back to app, web to outside, etc. You want to define all these parameters, long list of parameters within one file, within one folder. Then you can go and check the. So once you have the variables, then you can go and check the service graph is something that you want to create in between different type of EPGs. But before service graph, you should have the understanding of how the redirection of traffic is happening within the ACI. So you can see that in terms of programming, you have L4, L7 service graph template, you have template node, you have the service graph template C1 connections, means how the firewall will connect with different EPGs. All those logics. First of all, we should know all these logics, that how these things are happening within the ACI, how you can go and do the provisioning of L4, L7 within the ACI. Once you know these functions, the functionalities, then you can write within the program. So you can see that we have the complex program, and this is also one of the resource, right? So we have variable as a resource that we are going to reuse. We have the service graph, then we have the networking as well. Within the networking, what you want? Networking, the outside communication, the BDs, the movement from web to app, app to DB, the service bridge domains, how they are configured, how they are connected, all those logics you are defining within the networking file. Then you have the groups. In the groups, you can go and define, because you have the VMM integration. So create the EPGs, and these EPGs, maybe what is the domain for these EPGs? They are part of physical domain, or they are part of the virtual domain. If they are part of virtual domain, then you can go and define the VMM domains. Then define who is the provider, who is the consumer, because it will be used within the contracts. Then you have the contract. You know that who is the provider, who is the consumer, in between the provider and consumer. Do you have service graph? All those things you need to go and define, right? And finally, we have the main function that the main function is there that will tell you, okay, this is my provider, this is username and password, this is my tenant resource, and then you can go and utilize your uh, Terraform CLI commands like Terraform initiate, Terraform plan, and Terraform apply. So this will be fully this entire configuration with all the EPGs, with all the BDs, SBDs, with all the service graphs, with all the contacts in between different type of EPGs, full-fledged. This will get deployed within 2 minutes within the ACI. So full-fledged configuration you can do via the infrastructure as a code, and this will be your deployment method. Now, if you want to do this via the GUI, we have option to do this entire configuration via GUI as well. It may take maybe 1 to 2 hours with some errors and all. But if you know that logic, still you need to know that how ACI is working. So you need to know different things that what exactly you want to do via the automation, via the script. Suppose if you do not know those things, there may be chances that you will go and do some misconfiguration, and then it will be very difficult in future to find out that where we are doing some misconfigurations, right? So understand that particular infra fully, and then we can go and use Terraform as an infra as a code, and then we can provision the resources. All right, let's just stop here. Good job, everyone. This to last subsection of section 2.9. In this section, we have to understand the different type of states that we have within the Terraform. Now, if you know about a state and a state machine, that is one part of the computer science or computer engineering, where we are learning about different type of states. In the same fashion, Terraform is also maintaining their states. Even if you go and check Cisco devices, within Cisco device also, they are maintaining the running configuration in different state. So for example, if I am working on Cisco SD-WAN device and I can go and execute any command until unless I'll go and commit those configuration, that will not push to the devices. So that means that the devices, they have some uncommitted configurations. That means they know the configuration, but it is not saved. And then finally, we can save it to the RAM, and then you can save it to the NVRAM as well. Like that, different states will be there. Here also, you will understand that Terraform also maintaining different type of states. They have the state table, and they are maintaining the state table. So here you can see that this state file allows Terraform to map real world resources to your configuration, track metadata, and improve performance for larger infrastructure, right? So different states will be there. When we are starting building the Terraform file, then we have the Terraform file that is locally stored. And then if you want, so you can run that file, and then you can make a copy, means Terraform can have some backup as well, backup file as well, that can be stored in some shared location, some shared secure location. So for example, you can see that state file. By default, Terraform store the state file locally in the terraform.tf state. But for collaboration purposes, we can store it over the cloud secure storage as well, right? Even if we have that remote state management, means if we are maintaining those files over the cloud resources, then it is easy to do the collaboration. Here you can see one of the backup file stored in AWS S3. That's one of the example, state locking using DynamoDB. Right. So likewise, we have the state that we can store somewhere in the secure public place, and collaboration can happen, and obviously we have one copy, so that will be secure. We have to make sure this thing that the state files that we are saving somewhere or storing somewhere, it should be secured. Now, before coming to this particular slide, we have already executed these commands, right? We have done this Terraform initiate or init, plan, apply. At least these three commands we have executed earlier in our lab section. What this init command will do, that it will initialize a working directory containing Terraform configuration file. It also used to configure the backend. Then Terraform plan, as name suggests, create an execution plan showing that action Terraform will take to achieve the desired state. So important thing here is that you have one state and you want to reach to some state. So the state you are currently in, that is your present state, and then you want to reach somewhere that is your desired state. So the plan phase is something that will help you, means it will be ready to do everything that you can reach to the desired state. And once you go and apply, once you go and use this apply command, then it will try to reach to the desired state. So present state should be reaching to the desired state because it is done in the planning stage. And if you are getting any error, any problem in the planning stage, what does it mean? So it means that some problem in the resources, some problems in the variables, some problem in the syntax, etc. So you should go back and check your configuration, check your resources providers, and then you can fix it, and then again you can go and apply it. Apart from that, there are so many other states as well. So for example, Terraform refresh. If we go and use this command, updates the state file within the latest information from the actual infrastructure. So whatever actual is running, if you do the refresh, it will go and update with the latest file. Then if you want to destroy the resources, then you can go and use the Terraform destroy. Right. Again, you can see that we have a state related commands as well. Here you can see the list related to Terraform state. The Terraform state commands that will inspect and modify the state file, right? A state file. First of all, we can go and run the command Terraform state list. So what it will do, list all the resources in a state file. Then we can go and see, so the attributes of a specific resource, Terraform state show, and their attributes you can see. Then you can move a resource to a different name. So you can go and use Terraform state. That's the starting. Move source to destination, very much like Linux command. And suppose if you want to remove a resource from the state file, so Terraform state and RM for remove, and remove that resource file. One example here, we have gone through different type of examples earlier in our section. This is just for reference. Now, if you have this example and you want to run this program, so what you will do? First of all, you will go and use the init command. So it will start that program, then plan, make sure everything is working, and you want to move from present state to the desired state, then you can apply. If everything is okay, it will get applied. Then you can go and check the state list, right? And suppose you have a specific resource that you want to see. So again, you can use this command Terraform state show. For example, here ACI tenant example tenant1. Then if you want to modify the state, same thing that we have checked earlier, the commands that I want to move ACI tenant example to ACI tenant new name. These are very much manual and not recommended commands, but these options we have while doing the troubleshooting, while doing the initial testing. You can go and utilize these commands just to make sure everything is fixed, everything is in line, things are good. And finally, you can see that refresh command and destroy command that we have already discussed. What is the best practices? Best practices, we know that if you want to say, if you want to store something, make sure that is a secure location. You try to take backup regularly. You try to do not do the manual intervention all the time. Try to use automation. So create one automation script that is final in terms of that you have done all the testing, and then you have final automation script. Try to use that automation script and do not to use more manual editing and manual configuration. Secure your state files, and then finally keep the state files clean. Remove unnecessary resources, even unnecessary codes as well if it is there. Remove those and try to keep all the files clean, neat and clean. So clean the file, state file, save the state file securely, minimize the manual intervention, back up the state files regularly, and make sure that your remote storage is good, and try to use the remote storage for better collaboration purpose. All right, good job. So in this way, we have completed 2.9. It was a little bit big section, but we check all the boxes, and now we are ready to move to next section. Good job, everyone. Have completed section 2.9. In section 2.10, we have to learn about Cisco Orchestrator, Multi-Vendor Orchestrator, NSO. NSO is there that can manage multi-vendor devices. From NSO with automation, you will go and you can manage a number of devices and different vendors, right? Now, what are the topics we have here? So CCI exam will expect that you should know the NSO, the framework, and then with help of NSO, you can go and manage the devices. So you should go and learn Cisco IO CLI NED, and you should learn about the templates as well. Various options we have related to template. At least you should know Python and template. With Python template, you should go and manage the devices. Here you can see the list of topics that we have. Create a service template from a provided NSO device configuration. Create a basic Yang module for service containers. And what is mean by list, leaf, data, etc. Create basic action to verify operation state. And then finally, the NCS Python VM log file. Monitor service status by reviewing NCS Python VM log file. So these are the topics you can see. Now these topics are something that is not from zero to hero, like a topic they are starting from somewhere. So it is expecting that you should know NSO. And in case if you don't know NSO, then it will be difficult that from NSO platform you should go and manage these services, right? So what I have done, that I have created one nice playlist. This particular playlist will help you to understand that what's the utility we have with NSO, and it will start with the basics, basic small programs related to NSO, such as template only, single namespace, determine the configuration to use a service model, edit the service model, that Yang model, edit the XML template file. Means we have option. We have option. We have two options actually, that you can go and use Yang and then XML as encoded data format, or as a data encoding, or you can use XML and then Yang. Even we have hybrid option as well. So those options we have, that you can go and use the test the device service model, then template only model, 5 namespace, and then you can see that the edit the service model XML. You have good examples in these small videos. One video is actually 17 minutes. So you have total 1, 2, 3, 4, 5, 6, 7, 8, 9 videos. And I have covered these topics: 2.10a, 2.10b, 2.10c. So once you go and complete the 9 videos, you'll go and complete these 3 sections. Then I will go and start 2.10d, where we'll understand about monitor service. Okay, so please continue your learning. Please go and complete these 5 plus 4, 9 videos, and then we will go and learn about 2.10. All right, so let's stop here. Let us discuss about the service modeling methodology, what methodology we have to build this service model approach. Now, first of all, you have to identify the service. In our case, I am using SNMP. Likewise, we can have services like DNS, AAA, DHCP, etc. Then we need to identify the configuration on each device as a part of service instance. So is it a F5 load balancer configuration with respect to SNMP or Alcalucent or Cisco or Juniper? All those things we need to identify. And finally, in my program, which particular portion is static, which particular portion is variable, that I need to define. So for example, in our case, first of all, I configure a lab with a single device. It's a single device Cisco. So at that time, that single device is a static part because I know one device. In other lab, I have device 1 to device 5. There I haven't defined a device, means I can take either 1, 2, 3 or 3, 4, 5 like that. So at that time that device counts are variable. Okay, so that thing you have to measure. In this model driven approach, what we have, you can see the layers of protocols here. We have layers of protocols, say protocol layer, we have NETCONF, then encoding XML, then transport HTTP, and then YANG model that we have used in this particular section. What is the service model construction? That is again important. That what construction we have actually two options. One option is top down, other option is bottom up. What is the difference? So suppose if I built my YANG first and then my XML, obviously after that I will reload the package. So that approach will be top down. From top we are going down. Bottom up is that first of all we are building the XML and then the YANG. So whatever approach we are using, it's okay, it's just the reverse approach that we are using, and in this section I have used the top down approach. What devices I took? I took Cisco ASR, ALU, Juniper, Cisco IAAS. So this is redundant here, but Cisco IAAS I took, and then the F5. So 5 different nature of devices I took in this particular section. Now let's discuss about NSO service model types. You can see here either I can use the normal CLI configuration, means I can go to my NCS, I can log individually to the devices, and I can configure with help of CLI. That nowadays we are doing in the current infrastructure. We are logging to the devices via telnet or SSH, and we are forcing or implementing the configuration. Some of the devices like Nexus OS or other high level or high end devices, we can create template and we can push the template to the devices. That is also good. Now the use of this template, means this template driven approach, that mainly used for one time, rarely changing devices or device group configuration. So I have one template and I am using that template. Now in this particular service model approach, we have service models and it's very flexible. It's highly repetitious. I can use it n number of times irrespective of device A, B, C or D, E, F or like that. Means I can apply this, say, template, or I can apply this model n number of times without any service interruption, without any problem. It's a highly dynamic configuration, means I can change the configuration according to my service models. So I have a lot more flexibility and manageability options if I am using service model approach. Now why is so? Because we are using the YANG service model approach. In YANG we have some define model. So say leaf list, container list. What is the basic difference between them? That these leaf and leaf list, they have some type and value, and this container list, they don't have type and value. So leaf node with name, type and value, no children, they don't have children. Leaf list, sequence of leaves, sequence of this is this, and then I have container and I have list. In my example I have used leaf list, leaf access and the list. So you can see the list of the data instances generally with one or more keys. Let me show you one example quickly that I have used in my lab. You can see here that in list I have key and I have data instances. In leaf, I have type value. In leaf list also I have type value. In leaf access also I have type value. Okay, so these are the basics about the models. Means these are the building blocks of the models. These leaf list, and all these things. And in this service model driven approach. In this case, we are going to create one template with single namespace. That is the Cisco IAAS. And in the upcoming sections, we'll use that template. Okay. So let me go to my CLI, and from there I will verify all those things one by one. Here I am in my CLI, and let's check the folder. So let me go to my home Cisco, then NCS 4.5. Let us check the packages here and all the folders. I have one package here. So if I go inside that package, and if we check that, we have nets, services and tools, correct? Let me pop out from here. Let us check what the other stuffs we have. So here you can see I have netsim and some other extracts. Now what I'm going to do, let me show you that we have the device inside the device list. So let me log to the NCS, and the same I can use. It's telling the command not found. That means I need to set my variable. Let me set my variable here. Once I set my variable in this NCS run folder, then I am able to log in. Now let me clean this here. Here we can check the device list. Whatever devices I have, I can check that list. Now you can see I have added Juniper and iOS XR. Now what I can do here, I can request. So let me check that. Can I do the request sync? Let's check what are the other options we have with our devices. We can check this sync as well. Okay. And now you can see that sync result. All the devices are in sync. Now other thing what I can do here, I can check the packages and the operational state. So here I can see that packages, these packages, there is one more package called SNMP set template. I don't want to use, I'm going to create my own SNMP template, and then we'll check the status. So here you can see that up to Juniper everything is up. Now let me show you other stuff here. If I log in terms of Juniper, and then if I go to configure, now here if I check this package, so let me check what other options we have, because whatever things that we are doing with Cisco type of access, we can do with the Juniper as well. In Juniper we need to use run, show, and then package, then the packages, then the upper status. Okay, so it's fine, it's okay. Now next what I want to do, I want to create the SNMP model. and here you can see that I want to create a template only service model skeleton. So this I want to create. To create this I need to verify certain things. So let me verify those things first. What I can do here from now, I can exit from here. I can go to my say package. From package I can check my package. So let me check this and help. Let me scroll this up so you can see this output, the help output. I'm concerned about my say Python template. Okay, and if I go to NCS package and if I want to create a package, say service skeleton template, and this will not do the auto completion if you type tab. Okay, but what will be there if you type tab twice? It will come here in the down. I want to create template, say for SNMP T1, that's the name. If your command is correct, then it will take. Otherwise, what you can do, you can go to NCS make package and take help from there. If I scroll up and go up here, this I want to create this NCS make package, this one, the last one, then the service skeleton type, and then the package name. So let me use this. Let me copy first up to this point, go down. Okay, and then I can give say template and then say SNMP T1. Now once this is done, I can check this. So what I'm interested about, that I want to check that the source is young and the XML or not. So if I scroll up, 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 the source, that's okay, the young and the XML. So that's very much okay with this particular section. Let me close here. In the next section, we'll continue from here. It's very important to know your exact configuration, that on the top of which you want to build your service model. In this case, we have the SNMP service model. So what I will do, I will go to the CLI, both in terms of Cisco and Juniper, and then I will build the configuration. Once we build the configuration, then we have the option that will help of commit dry run output format. We can check that configuration. Okay, so let me show you this, that how we can do that. Let me go to my CLI. I'm here, log to my CLI. Let me log to my NCS. Say in Cisco format, I can use capital C. From here, I can build my SNMP configuration. So what I can do, I can go to the configuration, then devices, device. The first device is say C0. And for this, I want to do the configuration. So I can go to config, and then I have this. Now I want to select SNMP from here. So let me do that. Say iOS. and that is SNMP. So we have that filter option as well. You can see I can use SNMP. Now for this SNMP, my community list. So what community I want for this? And here be very careful that we have option related to SNMP and SNMP server. I want to configure SNMP server with community. My community is say let's use gig. So giga net, that is my read write community. That's very much okay. Likewise, I want to create one read only as well. So let me use read only, the community string and the read only. So say giga net and in the reverse net giga. Okay. So you can see I have two configuration related to SNMP server community giganet and net giga. Now if I want to see the output, what I can do, I can do the commit, say dry run, output format XML. This is my XML output format. You can see here. So my device name, then config, community, giga. I don't have access list for my community, the string like that. Okay. At the moment I don't want to commit it, so I can exit from here. I can go to top. I can end. I'll type no because I don't want to do anything. I can exit from here now. Now this time I want to check in terms of Juniper. For Juniper, you have to go like this, switch CLI, and then I can go to config. So you can see here we have the switch option, both the places. I can switch from there as well. Let me exit from here. Actually, I want to use Juniper, and from here, if I do the config, see, in this section we'll edit the service model, that is the Yang model file. So what I'm going to do, I'll go to my SNMP folder and then I'll go to the Yang, and then with help of my VI editor I will edit the Yang file, because in this case I want to edit this in terms of my SNMP service. Okay, so what are the things that I'm going to change into the default program? That obviously those things will be related to my SNMP service. Here I'm going to apply SNMP service to one of my Cisco device where I have my SNMP template. Then I have my SNMP community string, and over that I have either read write or read only access. So this access, you can see that it is done via leaf access in terms of enumeration, read only or read write. Then the community string, so I have this leaf community string defined here, and the leaf device I can check which device I am going to use from here. Then I have the common SNMP template which will be here. Okay, so doing all these things, I'm going to import one tailf common function as well. So I will import that as well. Let me show you all these things in CLI. Let me go to the CLI. I have my CLI here. So from here I can go to my source and then Yang. Okay, if I do ls minus la, you can see this is my Yang file. Let me go inside SNMP Yang. Okay, so here you can see this is my default template, and here I want to add some lines, so let me add all those things. First of all, I want to add, say, import the tailf common, and then prefix is tailf, close this. Okay, then I have this list snmp t1, that's okay. Key name I want to give, my key name is, say, community string com.str, that's okay. So here you can see the browsers, they are open, and then we'll check where it is closed. So it is open, means we are writing the common template for my list. Inside this list I have leaf name. So leaf name, before changing that, let me add info here, say tailf info, and that is my snmp server community string. Okay, now what I want to do with this leaf, that my leaf is, say, community string, and then the type is obviously the string, so that's okay. So we are very much done with this particular section from here to here. Now the next section you can see that, let me show you the full program here. So we are getting one note here that may replace this with other way of referring the device. So let me change these notes, and what I can do here, that I can write my own notes. Say change this to leaf for one Cisco iOS, something like that. We are writing this code for one device. Now here what I can do, that I can add a leaf. So let me add that. Say leaf device, and I can give, say, tailf info, that say pick any one Cisco iOS device, something like that. So what basically I'm doing here, that I'm adding a option that you have to pick a device. Then we have the leaf list device. So let me do one thing here, because I am writing this only for one device. So what we can do here, we can remove this line. I don't want list, I want only one device. So that's why I've added the information. Rest is okay, this is okay, the path is also correct. Then finally we have this notes that replace with your own stuff here. So what I can do here, I can add, let me scroll down. So I can add my leaf device here, and for that leaf device, what is the access level? Because finally I have to add the access, either read, write, or read only. So that's why let's add those things. So let me delete this line, because leaf access I want to give enumeration. Here I can add the info first. So you can see the structured programming, that what I am doing. Specify read only or read write access. Then we can go to the next line. Next line I can add, say, type enumeration. Then what is that type? The type is, say, enum, either read only or read write. Now finally we can put notes here that this is for, say, leaf access. So we come to know that where I am closing my braces. Otherwise, if any of these mismatch parentheses, I will get error while compiling this. Okay, this will be, say, list snmp template, this one. So let me match it quickly. This one is open, so this is closed here, this is, and this is closed here and here, this is closed here. Type enumeration I need to close. Okay, so you can see that you have to match all the parentheses, and I have to go up here and I need to close this. So this is closed here, leaf access closed here, then this one, and then finally we have the first program, that is the list T1. So I'm very much done with this program. Let me compile this and let us see if everything is correct. Then without an error it will execute, otherwise we'll get the error. Okay, for that let me go to one step back here. If I do ls minus la, then you will see that I have this make file. Then what I can do here, I can make, say, clean all, enter. Here you can see that I am getting one error, unterminated statement for enum. Okay, so let me go to yang vi, and where I have this error, let me correct that. So I have to go here and use the semicolon, go here, use the semicolon, then escape, write that. Then again I will go one step down and I will execute this. Okay, so I have again one error here where it is 21, 27, 35, undefined prefix tailf. Okay, so we'll do that as well. So these things you have to do while you are doing the programming. You need to improve all these things. I log to the program and I am correcting it. So whatever tail I have, I need to use tail F. Then again we'll go to one step down. Again we will execute this program. Now it is successful. Okay. In this section we are going to edit our XML template file. So for that I need to go inside my template folder and then I have to open my SNMP XML file. Once I open that file, then that file look like this, where I have to define the device, and we have some placeholders. Here you can see that, okay, you can edit these sections. So we will edit these sections, but not only the devices and the name of the device, but we need to add what is our configuration template here, and those things or those variables will be taken from my Yang model. Okay, so I will define those things inside my XML, because this XML package I am going to run. Okay, so let me show you that what are the changes I'm going to do in this. So changes, here you can see that I need to define. So first of all, what device I'm going to apply this. Then the community, say name is community string. Then what is the access? Either it is a read only or read write. Okay, so once I will define all these things, then I need to execute this. So for that, I will go log via maybe Cisco or Juniper style to my NCS, and from there I will reload the package, and then we'll check the package. Okay, before reloading the package, what I have done in my device instances, I have added some devices like Alcalucent and F5 load balancer as well. So those instances also will see in the package output. Let me log to the device. Here I am inside the template. Let me edit the SNMP XML file. Here it is. Now what I'll do, I'll remove the placeholders. So let me remove them. And then I want to add, say, device. That device name is okay. Then inside the config, so let me delete these things also, because I'm going to add my configuration here. Let me add those configs. First of all, I want to add the SNMP, say server. So here is XML NS iOS. Close this, go next. Add the community. Inside that, say name, and then I have to define the variable. So let me define the variable here. That is taken from the Yang model. Then let me close this. Name. Okay. Then what I have to do here, I have to define, say, read only, when it will read. So give that as well. Say starts with access. So with, and then I have to define the access. Access will be, say, read only. Close the bracket, close the parenthesis. So whatever things related to, say, programming, that whenever you are opening a braces you have to close it, you have to use all those things here, then close this as well. Otherwise while compiling it will throw an error. Okay, so the same thing I am going to do here. Only thing here is the read write, and when starts say with access read write. Okay, and then this also we can close. So far we have done the configuration for the community string. Let's close this. Let me close this community. Done. Then let me go and close the SNMP server as well. This is also done. So we are very much done. You can see only 3-4 lines of code, but you need to understand that these things will be called from the Yang model. So we have configured this, say device, then the device name, then the config, then the access, and then we have closed all these strings. So let me write it. Now next what I want to go to my NCS CLI. Let me log in terms of Cisco, and from here I need to reload. So I need to reload the package. So package reload, and if we get something like successful or two masses for my SNMP XML, that means that configuration is correct. Obviously the package will reload successfully, and then what I can do, that I can check that package status. Okay, the package status means the operational status of the package. So give this to 1 to 2 minutes. Once it will come back, then we'll check the result here itself, and we'll check the operational status. You can see here reload result is successful. Now I can check the packages, say SNMP. I just want to check my operational status as well. Show say packages, yeah, operational status, and here we have SNMP, that is up. We are very much done with this section. Now we are done with our service model. In this section we'll implement it over Cisco IAAS, and then we'll verify it. Let me go to my CLI. I logged in as a Cisco CLI. Let me configure it. My SNMP, let me check. I have my template. Then what I want community string, say that is my giganet. Then if I type question mark, access, it is asking what access level I have. For this I have read write. Now I can give the device, let's say C0, and we are done. Likewise, I can go to the same template. I can give say net giga, access read only, device is C0. Now what I can do here, I can check my, let me go to the top first. Now I can check the commit. So let's do that, commit and then dry run. No capability found C0 has a sync from device has been performed. So it is telling that you can sync from. Let me do that. Will not write this. We'll do one thing. We'll request to sync from. So let me check the available options I have. Yeah, I have sync from option. Let's wait for a minute. Now it has been synced. What I can do here, I can check the package operational status. So let me do that. Say show package. Okay, let's go back and let's do the configuration for my say SNMP. Before doing any commit, let me check this, and I want to check commit dry run. Yeah, now it is showing this that CLI local node data device device C0. You can see all these plus these things that I am adding here. Let me add one extra line here. This time what I want say net giga and then the device access read only. Okay, now I can go to top and again I can verify the dry run. So here we can see that I have iOS SNMP where read and write and read community. The template is this. Okay, now what I can do here, let me commit this. Commit is completed. Now I can go out from here. If I type SNMP, say giganet, we'll check the sync-conf info in sync. Likewise, the netgiga will also in the sync. Let us verify the SNMP T1 and SNMP giganet. Okay, then netgiga, that is also okay. Now if I exit from here, if I do switch CLI and configure, if I go to the Juniper mode, from here if I check show SNMP T1, now you can see this in the Juniper mode as well. Let me go back to the Cisco mode. So this is the way we can check. Now what I want to do here, let me go back to my NSO, and inside NSO if I go to netsim CLIC say C0, so if you are in the correct folder it will give you the output. Yeah, so I am inside C0, you can see this. Now from here also if I check show running configuration say SNMP server, now we have this expression or this configuration that is we are using in Cisco iOS. Okay, so this is also there. So you have seen three things here, that from NCS admin I can go to Juniper, I can go to Cisco, check those things. Then what I can do, I can go to my NSO and then from NSO I can go to my NetSIM. From there I can go to that device and then I can check in that native Cisco format. Okay, so you can see this much of options and possibilities we have that we can verify. Okay, let me log back to my NCS. So I can go to NCS CLI U admin Cisco, and from there if I want to check the metadata, so that option is also with me. I can go to C0 and then say iOS. Let me type question mark here. So what I want to do here, that I want to check the config first. Seems that I'm missing something. Say device, and that is the thing, if you are running in Juniper mode, then you have to use some other strings. If you are running in Cisco mode, then you have to use some other strings. Okay, so that is also one thing that we can learn. I want to check the config. That config is iOS SNMP. Then it is asking about exec and default. So let me check this. That option is there in the Juniper mode. So you have to type this show device 0 config iOS SNMP server display service metadata. If you press enter, then you will see here what is the reference count, because this time we have created these service model just to refer one device. So you can see the reference count and the string, all those things. In this section I will show you that with 5 namespaces how I can build my Yang model. The remaining namespaces or the devices are Cisco XR, F5, Juniper, Alcalucent. First of all, I will create the package name template5, and once I created the package, then I will go and first of all I will check the device configuration and the XML output. Once I'm done with that, then I will go and create or edit the Yang model. Once I edit the Yang model, then on that I will go and change that Yang model, and then I'll compile that. Okay, so these are the steps that I'm going to follow. Let me go to my CLI. Here I have my CLI. First of all, let me create the package. So NCS make package, then the service skeleton, that is my model, and the template, say SNMP template 5. We are going to do this for the 5 devices. Now once I'll do that, then what I can do, that I can go to the SNMP template 5. I can check my, you can see I have this XML file as well. Then I can say, if I do say cd source, if I find, I have this Yang file here. If I go up, here if I do the find, okay, so I have both the skeleton created. One is the template and one is the yarn. Now next what I want to do, I want to go to my device, and from there I want to check the configuration. So let me go to the say Cisco format, say C. Now from here I want to say configure my XR device. If I type question mark, I have XR0. I want to do the config related to Cisco iOS XR SNMP server, and then the community, the string I can give say giganet, and then the read write access. Now this I want to check the XML output. So let me do that. I can check show, or I can do like this, say commit dry run, and then the output format I want XML. Here you can see this is the structure of XML file, and here we have the SNMP, community, name, and the read write access. What I want to do this, I want to exit. I don't want to commit this. Now let me show you this with respect to Juniper, how we can do that. Again, you have to go to device. Then this time the device is say Juniper. You type question mark and then you will get the options as well. I want to configure Juniper, say for Juniper I want to configure the uh, June OS SNMP, say SNMP, and then the then the community. You can see here, let me type community, then the name of community I can give say giganet, then I can give the access label. So what I can do, I can do the authorization, suppose read only, so say read only. Let me check there. Yeah, read only. Now I can go to commit dry output, so commit dry run output format XML. Here I can see the structure for Juniper. Okay, here the other thing, we have this authorization keyword like this. Parallelly I can go and check the structure for F5 as well. So let me check for the F5. Again you have to go to devices, say F5 load balancer, and then obviously configure. So I have that config. Only two option I have, big IP. No, we have option related to big IP, and you can see that what big IP you want to configure. Uh, Big IP say system, because this is system wide configuration. Then the question mark, let me type what are the other options I have, say SNMP I have, and then SNMP communities I want to check. Okay, community name say giga net, and then obviously I have to give the access is say read write. I can go to top, the same output I can check to view the output, Now you can see the structure for F5 load balancer as well. I don't want to write it. Then finally I will go and I can check the Alcalucent as well. So again I can go to devices, device say ALU, config I want to do for ALU, system, security, say SNMP, community, say GigaNet. Anyways, if the name is there, then I have say read and write. Again I can go to top and I can check the commit output. Here you can see even I can use the hash keyword as well. I haven't used it, but you can see after GigaNet the type is hash2 and then the parameters like that. This also let's cancel it. Now what I have to do, I have to format my Yang model. So I am going to check my Yang skeleton and it should be there in the source. So let me go to the source. Let us check the Yang. Yeah, I have this Yang. Go inside that. Now I'm going to uh, improve this or format this output according to our requirement. So let me go to vi snmp Yang and this program I'm going to change. So whatever things I'm going to change, because in the last examples we have done something. Here also, first of all, I need to add. So I need to add the tailf. Let me add that. Yep. Let's add. So import that tailf. Last time I have done some mistake uh, there to writing the tail. I excluded the f, so that's why I got some error. But finally we have modified that error. We find where is the problem. So suppose if you are writing anything and if you have some error while compiling it, it will generate that output that in this particular line you have the problem. Then you can go and you can improve that. Okay, so I have added this. That's done. Then I will go to my key name here. The key name I want to give say community string. That's okay. Then I'll go to my leaf and the leaf name I can give say community and then a string. Type will be a string. So type is okay. What I want to do, I want to add one info here, that is the tailf info. So tailf, not trailf, tailf info, say snmp server community string. Correct, type is a string, that's correct. Now let me scroll up to down till here. And once we change the string, then what I want to do, I don't want to add any device because this is not specific to one device. So I will not add that. Then I will then what I will do, that I need to add the leaf access. So let me leave this portion. I don't want to use this portion. Let me go to this section, and this section I want to add. Yes, adding my stuff. Let me add. Leaf, what I want to do here is access, okay? And then this type, let me move all these things. Let me use our program, say tailf info. So here I want to specify either read only or read write. Yes, that's okay. Then I want to type enumeration. Then the enum is say read only or enum is read write. We are almost done with the programming and the changes here. If everything is correct, then what I can do, let me write this. And once I write this program, then I want to compile it. Okay, so let me do and compile this program. So what I can do, I can go to cd in my source. I can type say make clean all. If everything is correct, we'll get the output. Otherwise, we have to go back and improve the coding. It is telling that you miss this where invalid keyword start character. We have this problem. So let me go back and change this. We'll go to Yang VISNMP. So I have given one extra parenthesis and that's why I have the issue. So let us check that. Extra comma actually, not parenthesis. Here it is okay. Telef info it is okay. Here in this section, what you can see here that I have given one extra parenthesis here. Let me remove that. So now it is okay. Let me rewrite it. Let me go back. Let me compile this one more time. Still it is throwing an error. Unterminated statement at keyword type. Let me go to the folder one more time. Let me type SNMP here. Let's rectify that. Here I can find this type is not defined, so let me go and define this. And that's why it's very important to check all these things. So finally, this should be closed here. That's okay. Leaf access should be closed here. That's okay. Let me scroll down. So two are done. Then I have list SNMP. So it should be closed here, and then I have one final. So let me add one more parenthesis here. Let's write it one more time. Go to source. So let me go to source. Say go back, go to source, make file. Finally we have done that. Okay. Now we are done with our Yang model. Let's go and complete the XML template. Now, because we have 5 devices in this case, so what I have to do here, first of all, I'll go to the template and then I'll open my default XML template. Then I have to add the configuration related to iOS. This configuration we have done in our previous example. Then I will add configuration related to, say, iOS XR. Okay, and you can see the community and name. So whatever we have seen with respect to their native configuration over the CLI, the same type of thing you have to do here as well. Okay, so you can see here the iOS and iOS XR both are very much similar, but when it comes to Juniper, we have to define SNMP community string. Then here we have the option read only or the write only. Then we can close that. Even if I go to the other, like if I go to ALU, here you can see we have difference in the configuration. That's why we have difference in the XML as well. So I have to give type as a hash, and then I have to define the access parameters, then community as it is. Even in F5 as well, you can see the name community string, access label community is like this. Okay, so what I have done here, that I have those things in my notepad, all these configuration. I'm going to simply copy and paste to the default configuration. So let me copy up to here. Let me go to my CLI. Let us check that I have that XML file. So I need to go inside the templates and let us check. Yes, I have this SNMP XML file. Now in this I want to edit. I have already copied. I want to paste here and I want to delete few lines here. Okay, so let me delete some lines from here. This is the comment actually. You can give the comment if you want to. Let me delete. I have deleted up to here. Let me edit this config bit. So what I want from this config, this will tag and it will merge. Okay, then again I have these comments here. Let me delete these comments because I'm going to use my comment. Let's delete it. Now in this configuration portion I want to paste whatever I have here in the notepad. So let me go up one more time. Yeah, let me go up. Let me copy this first till big IP. Copy this, go back, paste. Okay, so once you paste, even we can verify here some of the configuration, and once I verify this, then I have to reload the package just to execute this. So from iOS you can see that read only read write the same that we have done. Then I have iOS XR, and the important thing here I have to verify that the device open, device is closed, name is open, name is closed, this config. So let me scroll down. Let me go down. Let me go down just to verify the config. Yeah, So config is there. Let me write this. Okay. Now what I want, let me log into my NCS CLI and I want to reload the package. So what I want package reload, and we'll wait for a few seconds. You can see the successful message here, and also we can check the package status, that is operationally up. Let us test this over the devices. Let me log to my CLI and then I will go and I will do the configuration over the devices. Let me go to the NCS admin like Cisco. Here what I can go do, I can go to my SNMP template 5 and then I can set the community string, say giga net, that is the variable I'm setting here. Then I can give the access, say read, write, and then I have the option for the devices. Devices I can take all. So I can give ALU, say C0 I have already applied in my previous section, so F5 J0, say XR0. Okay, now what I can do here, I can check the output, commit output, say commit dry run, and I can use XML format. So let me check what options I have. So output format, yeah, I have options CLI, native, and XML. First, let us check XML. Reference to the devices is showing wrong. Let me abort and let me do it one more time. So what I have done here, I have given the devices and then let me give the device name as well. So I can use ALU 0, say C0 already done, say FIP 0, Z0, XR0. Let me check the output. Yeah, so that was the missing piece there. Now let me scroll up from here and we can see this. Say for ALU, this was the configuration. Let me scroll it down so you can also see. Then F5, then Juniper, then XR. Okay, now if I want to check this output in say native, we'll see what is the difference. So for ALU, it's like very much the native one, but for F5 you can see it is in XML format, and Juniper also it is in XML format. Where is my XR? XR you can see it's in Cisco format. Okay, so Juniper and say F5, what they are doing, they are taking input as a native language, that is the NETCONF, in the XML format. So that's the difference. If I go and check the other output, that is the CLI you can see the plus, because we are going to add all these things. Suppose if you want to delete, then it will show minus here. Things are okay. Let me do commit check and then commit. Let me log to the devices one by one. So what I can do here, I can go to my NCS, say netsim, and from here, say suppose if I want to log into Juniper, the name is Cisco, but it's not Cisco. Actually the root name is Cisco. Okay, so we'll do show running conf configuration snmp, and this is the configuration we have. Now let me exit from here. Let me go back. Let me check ALU0, show running conf configuration. You can see you have the difference for all these outputs. Let me check this. Suppose if I don't know the filter, because that is the new device I am working first time, then what I can do, at least I can go to show running and I can search snmp. That is very much done. Exit from here. I want to check my F5 as well. So let me check my F5. That is FIP0. Let me scroll up. What's the name of F5 I'm using? Let me go up, up, up. Scroll up. F5 I am using FIP0. Okay. So what I will do, again I will go to netsim F5. I will do show run, and at the moment I have only this configuration. Okay, so this is the way that we can verify over the devices. So far we have added giganet. Let me add net giga as well. Let me go to the NCS CLI, go to configuration. This time I want to add the community string as say net giga, and the access role is read only. Okay, then I want to add devices. Let me add all these devices, and I want to edit some of them. So let me edit that. Say I don't want C0, I want C1. Go to top, say commit dry run. Let me scroll up so you can see this. And this will be very interesting output. So what this time we are doing, that we are adding read only. So all the plus plus you can see, all the devices we can see. Let me check this as well. So devices for NetGiga, correct. Commit this. So once I committed this, again what I can do, I can exit. Say I will go to the F5 and I'll check show run. Now we have this entry added here, and not only here, you will see everywhere. So if I go to say Juniper, say J0, and if I check show run, say configuration SNMP, here we have added these lines. Okay, so you can see that we can add at any time. Even if we want, we can delete as well. Let me show you that how we can delete this as well. Let me exit from here first. Exit from here. Let me go and log in terms of Cisco. Say I want to delete. Let me go up. In Cisco style, basically what we are doing, we are using no keyword. Let's use that no, and let's check the commit try run. Now here you can see all these minus signs. So that's why I execute this command. What it will do, once I execute this, then it will remove all these statements, all these commands, and let me do commit check. Yeah, but at the moment I don't want to delete it. Good job. In the last subsection, we have to understand that how we can go and monitor the service status by reviewing the Python VM log. While you build these services, while you're building your automation script, we have log files that is stored somewhere, and the name of that log file is ncs python bm.log. So in the specific folder, you can see that as per our directory, and it may be the actual path of our directory. So as per our directory, within the directory logs ncs, within the logs folder, we have ncs python.vm log, where we can go and check the logs. So for example, if we have some sort of error, if we have some sort of information that we want to go and check, we can go to that particular folder, that particular directory, and we can check this log file. Now, if you want to see this page by page, then within the Linux, we have this less command. You can go and use this less command, actual folder location, and then you can check the log file. Apart from that, we have the grep option as well, that we can go and utilize the grep option as well. So grep command that you want to search something. For example, I want to search my services in this VM. I can go and use the grep command and search specific services within my log file. So here one example we have related to log file. You can see here with the timestamp, we can go and have a look to my services running. Then you can see that service create service, applied service. So you can see all the timestamps that we have. And in case you have errors, you can see that at this particular time we have error related to services, failed to apply services, my services, right? And error details here. So like that, you can go and explore the error. It will help you to troubleshoot the issue. So suppose if you are encountering issue, and here you can see that the notes the point I have written. So you can go and identify the error, look for the error entry in the log file and note the error message and detail. right? Check what is that error, what it is telling, what it is pointing. So we can check the error code error, check the service logic, review the Python code in your service package, particularly the service create callback and the template. So check your program, your script, right? Your logic. Then we can go and check the service template related to XML template or related to Yang model. So XML template you are using. There you can go and check that all those logic that we have related to the template is correct. Then we can go and verify the device configuration as well. So what is expected? We can go and check the state machine that this is my configuration and this is the expected configuration. So you can go and match the expected configuration with the configuration, and you can check the diff, and you'll understand that the configuration is falling on those particular points or not. Finally, you can go and consult the NSO documentation. So if something is not means, suppose if you are not able to find out something is there which is not listed in point number 1, 2, 3, and 4, then obviously you can go and consult the documentation and you should go and follow the best practices, right? So you can go and follow these methods that is listed here in these slides, and you can easily go and search through the log file to monitor and review the services that is running. All right, let's stop here.